It's good. Glad you could make it. Tonight we're having a special one. It is a debate conversation, actually, between Luch and Sleeping Warrior. Um, and I think it's going to be very interesting. I hope you guys are doing well. Did you guys have a good day so far?
No,
Yeah.
my day's been terrible.
I saw Anthony sent me some photos of what he did today. He's going to be tired tomorrow and stiff. That's for sure.
It's been a
What
3-day
did Anthony
project,
do?
it's been a 3-day project, and my shoulders, my back, my everything's sore at the minute because I've been using muscles that I've not used for many years. My God, just don't start digging out fence posts yourself, because like you need to get younger people to do it. Once you get beyond a certain age, it's very difficult to bend down.
Yeah, that's for sure. And I think Luch, you just woke up actually.
Yeah, my day's just getting started.
What country are you in, Luch?
Australia.
This is the
The
first
land
time
down
we've
under.
this is the first time we've really got a chance to really speak. Am I right in thinking that the only knowledge of me that you've got is through your Superman channels, like your superhero channels? Yeah.
That,
So you
that would
think
be accurate, yes.
you think then that I'm stupid, that I don't understand science, that I deny science? You think all the things that you get told about me are actually true, correct?
Yeah, unfortunately.
Really? Have you never been inclined to speak to me to see whether I am actually stupid?
Well, people just... Well, flat earthers, you know.
Flat Earth is what?
Well, just people have negative things to say about flat earthers.
So you think that all flat? Do you actually think that all flat earthers are stupid?
And that's what I've been told, yeah.
Have you ever spoke to a flat earther before, other than me today?
I've spoken to Flatzoid.
More than once?
Yes.
Okay.
PJ as well. PJ, Crookshank or whatever.
So do you think that Flatzoid is stupid?
I can see how he thinks he's smart.
So in other words, you think I'm stupid.
Yeah, I'm sorry.
Wow.
No hard feelings, though.
Is it possible that you might be ignorant, given that you've not spoke to me before, and this is literally the first time? I mean, I know we had a couple of one-liners the other day, but like this is the first conversation. Is it possible, do you think, that you might be ignorant, and what you're being told by other people is just a hate slur because you have to ridicule flat earthers, regardless of whether they're right or not?
Well, because we have because they've, physicists and scientists and all that have been studying this subject for many years, and they've all come to the same conclusion that the Earth must be a globe. It's kind of hard to believe anything different.
Sure. Did you go beyond high school with physics or science?
No.
Did you finish high school?
Yes, I did.
Did you go to college or university for anything?
No.
Okay. All right. So we're brought here today because, correct me if I'm wrong, but you believe that the air that we breathe, is pressing down on us with weight. You think atmospheric pressure has weight, correct?
Yeah, air has weight.
Okay. Do you know what atmospheric pressure is defined as per your model, your understanding of it?
What's it defined as?
Just yes or no. If it's no, we can look it up. But if it's yes, then we can just agree and move on.
No then. I don't.
Your model tells us that atmospheric pressure is the weight of a column of air pressing down on you directly above you. That's what it tells us.
That
Do you
is what
do you agree
air
that's how it's
pressure is
defined?
defined.
Do you agree that's how it's defined, or do we need to check it to make sure that I'm not lying?
That is what you're saying air pressure is defined as?
No,
in our
that's
model?
not what I'm saying. I'm trying to give you, I'm steelmanning your argument for you so that you know that I understand your model. I'm just telling you what you guys tell us what atmospheric pressure is. It is a column of air pressing down on us from above. If we agree, we can move on. If we don't agree, we'll get it defined.
Yeah, I think. Yeah. By the way, yeah, I think that's true.
Okay, I'm not persuaded that you're convinced that that's the definition. We might need a definition. Flatzoid, would you mind?
Yeah, you guys go ahead.
Just go to Google and just type in atmospheric pressure and then definition. And then let's just see what it, because we can pick one that Luch agrees with or one that he's happy with, because I'm not persuaded that you're convinced that that's what it is. And I don't want to feed you with words for you to not be absolutely certain.
I'll have a look it up. I'll have a look-see as well.
Yeah, well, let's do it together. I want to try and get a common ground where we both agree, where we can start from, and then we can keep agreeing until the point where we disagree, and then we can see why we disagree and see what science supports or disputes it.
Okay.
Because if we can agree and agree and agree, eventually we're going to disagree, and then we can narrow it down to the point where we can establish one of us is right or one of us is wrong. So let's see what he's got. Have you got a definition there, Flatzoid? You want to read it?
Okay, I just got on your atmospheric pressure, the standard atmospheric. Sure, you want the definition?
Yeah, sure. Just type in the word definition at the end of it. Yeah. We might need to put with physics.
Okay. The pressure exerted by the weight of the atmosphere, which at sea level has a mean value of 101.325 pascals, roughly 14.6959 pounds per square inch.
Just give us that first 5-6 words again.
The pressure exerted by the weight.
The pressure exerted by the weight of the atmosphere. Okay, so the key word in that line, in that definition, would be weight. Would you agree?
Yeah.
Okay. In physics, we have a definition for weight. What is the definition for weight?
Do you want the calculation or?
No. I just want the definition so that we can agree that atmospheric pressure is a weight pressing down on you. If we can agree what weight is, then we can see, is it true?
That's. I have it here as well. Atmospheric pressure is defined as the force per unit area exerted against a surface by the weight of the air above that surface in the atmosphere.
Yeah, so your definition says weight as well, right? So both definitions agree with each other, and they're not. I don't disagree with either. Can we both agree that they both match and that it is to do with the weight? Can we both agree that?
Yeah.
Great. Now, we need a definition for weight. How do you guys define weight?
Let's see. What is the definition for weight?
Might want to put in physics, because sometimes if you don't put in physics, you get like a colloquial definition rather than a specific one.
Yeah, it's weight definition physics.
Okay.
It's better to be precise with terminology so that we can apply it, because if we do a layman's interpretation or a layman's application, it often takes us into different angles that we shouldn't really go in because it's wrong.
It says weight is defined as the force exerted on an object due to the acceleration of gravity.
Okay, so just two key words there: force and the acceleration due to gravity. Would you agree that they're the two key words?
Yeah.
Yeah. Well, what I'm going to do, we all know that gravity is not a force. We all know that gravity is the curvature of space-time, and it causes an optical phenomenon, a akin to refraction. It's demonstrated with the Eddington observation and scientifically demonstrated with LIGO. But for this conversation, I'm going to give you that gravity is a force. You can have it. You can have Newtonian gravitation, even though it's not current anymore and it's been superseded. I'm going to give it you. So just for this conversation, gravity is a force. Okay?
Wait, it said gravity is an acceleration there, not a force.
What was the second word you said? You said force, did you not?
It's defined as the force exerted on an object due to the acceleration of gravity.
Yeah, so it's the force exerted on an object due to the acceleration of gravity. I think that was what you said.
Mm-hmm.
Right, that's applying Newtonian gravitation. Do we agree?
Yeah.
You don't sound convinced with your own model here. Come on, you need to be giving me more confidence that you know what you're talking about.
Let's say.
Pick a different one. Pick a different definition if you're not sure. I want you to be happy that I'm not cherry feeding or spoon feeding you in any way, that we're going in the direction that you want it to go and you're happy. Because if you're happy, I'm happy, because when I'm ready to pull you apart, I will. But I want you to be happy first.
Yeah. Yes, it would be Newtonian.
So do we agree that your understanding, your model, your guys, your side of this conversation is atmospheric pressure equals a force acting on an object caused by the acceleration due to gravity? In other words, a downwards force. Is that where we're at?
Yeah.
Great. We have a big problem.
What's that?
That violates the Joule expansion of gas law.
Why?
Okay, we need a definition for the Joule expansion of gas law. It's also known as the free expansion of gas law. Would you mind doing that for us, Flatzoid? You're on mute, by the way. Okay, he's just pulling it up. It's called the Joule expansion of gas or the free expansion of gas. They're both the same thing.
So,
Yeah.
what violates it?
Your understanding or your definition for atmospheric pressure.
That it's a force?
We've just agreed that atmospheric pressure is the force exerted on the surface of an object caused by the acceleration due to gravity. Well, that means that all of the direction involved in this is all going to be in the downwards direction, because that's the acceleration due to gravity towards the center of the Earth, according to you guys, right? So just click into the link for Joule expansion on Wikipedia or any. There we go. What is free expansion of gas law, right?
Would that be a thermodynamics one? Law?
No, it's just a gas law. You've heard of what are the gas laws? The Boyle's gas law. You're aware of the gas laws, right?
Controls.
I'm only aware of the thermodynamics one.
No. The gas laws, it describes the way that gas works. As temperature increases, the pressure increases. As temperature reduces, the pressure reduces. Guy Lussac's gas law, Avogadro's gas law, they describe the behaviors of gas. Now, usually when we get to this point, I get told, but they're only ideal gas. They're only ideal gases, and we don't have any ideal gases. And they try and disprove them. But these gas laws apply in real world. But the main problem in the real world is that air isn't a single gas. There's many different gases in air. There's nitrogen, there's oxygen, there's carbon dioxide. There's a few gases. There's 5 or 6, 7, 8. Who knows? And it's a mixture. It's a compound, and they're all mixed in together. So it's not a singularity. It's a mix. Yeah. So the gas laws describe a single gas behaving in a particular way, but the air we breathe is many gases. So a lot of them say, well, it can't apply because we have many gases, and the ideal gas laws don't apply to many gases. And they are correct, of course. But the behavior of gases overall are described by the gas laws. Shut up. So we have to acknowledge that they exist, and this is the behavior of gas. I'm going to assert it don't make no difference whether it's a compound or whether it's a singularity. It's still gas, and it behaves differently to solids and liquids. But you're going to say, well, it's still pulled down by gravity. Just bear with me one sec. Right.
Shut up.
They're gone now. You're going to tell me that they behave with gravity and gravity pulls them down, right? Well, the free expansion of gas law, the dual expansion of gas law, states that an object... let's have a look. Where does it say? I can't even see it. The free expansion of an ideal gas comes with an array of intriguing physical alterations that extend... I'm just looking for the definition of it.
Would that be the conservation of energy?
No, I'm just looking for the definition of it. I don't see it there, Flatzoid. Can you get us the definition for this one?
They get the definition rather for you. Okay.
Please. There.
Oh, there we go.
Free expansion of an ideal gas refers to when the gas expands freely and instantaneously into a vacuum without any heat exchange or work done. It's an irreversible adiabatic process where the gas's temperature remains constant. Now, what the key words here are the free expansion of an ideal gas. So this is where they always say, oh, well, this doesn't apply. Okay, well, it does, but only because we have more than one gas in the air. But it says when the gas expands freely and instantaneously into a vacuum, right? Well, you guys tell us that the sky is a vacuum, but the gas expands freely, not with a directionality of down, and it's instantaneously. Yet we have the gas pressure staying here. Now, even with gravity as a force, I'm going to give you gravity as a force, right? We all know it's not, but for this, we're going to give it you. The free expansion of gas law, gravity doesn't affect it at all in any way. But you're going to tell me that there's a downwards pressing on us because that's what's needed in your model. But in real world, the free expansion of gas law states clearly that it expands freely and instantaneously into a vacuum, which you guys tell us the sky is. Gravity doesn't apply to the gas laws. It applies in your model because it needs to. It has to. But in real world, it doesn't apply to the free expansion of gas law. I'm sure if you do a bit of research yourself, you can find it yourself, and Flatzoid could probably find it now. But the free expansion of gas law, gravity doesn't affect it at all because gases are all very volatile. They're full of energy. They're bursting with energy. And because they're so energetic, there's a lot of kinetic energy in them. They move freely and randomly in all directions without any bias whatsoever, even with gravity being a force. A bit more research on that, you'll find it. But here's the thing. If we have a container and we evacuate all of the air out so it gets to a perfect vacuum and we get a single gas molecule and we inject it into that container, describe to me how you understand the behavior of the gas molecule will be. What will it do? I'll tell you what it'll do, and you can tell me how I get it wrong. It'll bounce randomly off all surfaces with perfectly elastic collisions, and there will be no directionality towards it. It'll be continually bouncing because the gas molecule is full of energy. It doesn't lose any energy when it hits any of the walls, and it bounces off them with an angle that is equal to its angle of incidence. It'll bounce off it with a perfect reflection. So if it goes in at 36 degrees, it'll bounce off with the equal angle going in the opposite direction. And it'll do that continually, bounce in all directions freely being the key word. But you believe there's a downwards directionality. So you tell me what you think that one molecule will do over time, please.
So in the scenario, you've isolated one molecule of gas inside of a container, and you want to know what it would do.
Yeah, I want you to tell me that how you understand that the gas molecule will behave. The free expansion of gas law states that one molecule, which will now apply the gas laws because it's only one molecule, it's one gas, it's not a compound, it's not a mixture, it's one. So the ideal gas laws do apply in this situation, and it'll bounce freely in all directions randomly, and it'll do it continually with perfectly elastic collisions. There is no net loss of energy. In other words, it'll just carry on bouncing in off all the container walls So if you've got a square container or a cube container, it'll just continue bouncing all the time. It'll never slow down. It'll never run out of juice. It'll always do it continually. Bang, 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 continually, right? There's no directionality to it. Applying the gas law, the free expansion of gas law, and it's demonstrable real world. But I want you to tell me how you understand it to be, because if there is a directionality of gas, then what? How does it change?
So your question is like, if you were to isolate a single gas molecule in a container, would it move freely in all directions forever?
No, I want you to answer the question I asked, which was, if you believe that there's a directionality of gas because it's got weight and it's being pulled down by gravity, which I'm going to give you. I'm going to give you that gravity is a pull. Describe to me the way that one molecule will work.
Considering gravity and stuff.
Yeah. Describe to me what would happen.
If a single gas molecule were in a container, were isolated in a container, I guess theoretically it would move freely in all directions within the container indefinitely.
So if you think it would theoretically move in all directions freely, then you're denying that gas has got weight. Air has got weight, because you're saying that there's no directionality to it if you use the word freely. Let me do it for you, and you tell me if I've got it wrong. Let me steel man your argument, right? And if I get it wrong, and you think that I don't understand, you tell me how I've got it wrong and correct it. Let me try it for you.
Okay.
If I'm going to do it for you and say that there is a directionality of gas, then all the trajectories will all be curving towards the center of mass every single time. It'll go from one side to the other, and it won't be a straight line. It'll be a curved line bending towards the Earth. Then it'll bounce off and it'll go towards the Earth or away from the Earth, depending on which angle it's hitting it at. But there will always be a curved trajectory towards the center of Earth, because gas has got directionality because it's affected by gravity. Therefore, gas has weight. If I've got that wrong, correct me.
If you want for something to be perpetually in motion, that would be no external forces acting on the molecule or the system itself. Meaning no energy is added or removed from the system.
So the behavior of the gas molecule would do. I mean, you're trying to tell me? Did I steel man your argument well, or did I get it wrong? That's what you should be telling me.
No, you got it wrong.
Okay, so correct me.
So, if you were to have gas in a container constantly moving forever, there'd be no external forces, but there is an external force acting upon the gas molecule, so it wouldn't really move freely forever.
So what would it do?
It would eventually lose its energy.
Oh, so you think it runs out of juice? It runs out of energy, but they're perfectly elastic collisions, so it doesn't run out of energy. These things are very volatile. They're very They're very agitated. They're full of energy. Perfectly elastic collisions. They don't lose any energy.
If it, like in theory, it would move freely forever. Yeah, in theory only, but in reality, we have other factors to consider, so it wouldn't really move forever.
What other factors might it? So what you're saying is, I didn't steel man your argument well, because that's only in theory it would continuously run forever. So in practice, what is the correction? Just give me the correction.
Under theoretically, okay, under ideal conditions and using classical mechanics as a guide, a single gas molecule in a perfectly isolated and energy-conserving container would continue to move indefinitely, right? However, real-world practicalities introduce complexities that would prevent this ideal scenario from being realized, underscoring the distinction between theoretical models and practical observations in physics.
Is that it?
Yeah.
Okay. So what you're basically saying is the free expansion of gas law doesn't apply in real world. Correct?
It still does apply.
Go on.
Let's say. Just give me a sec.
While he's looking for that, I just want to say hi to everybody that just joined. Please hit the like, share the show. Really appreciate it. If you have any questions for them, send a super chat and we'll keep it for just now when we have a Q&A.
The free expansion of a gas is primarily a theoretical concept used to illustrate and understand certain thermodynamic principles.
So your rebuttal is that
Particularly those related to entropy and the first law of thermodynamics. In these theoretical discussions, free expansion involves a gas expanding into a vacuum without doing work on the surroundings and without any heat transfer to or from the surroundings.
so you don't accept it because, according to the citation that you're reading from, it's conceptual, it's not real world, correct?
Yeah.
Okay.
It's primarily a theoretical concept.
Okay. Now, do you agree that the dual expansion or the free expansion of gas is actually a gas law? Regardless of whether it's conceptual or not, do you agree that it is a gas law recognized by science and it's not me making shit up? Do you agree with that?
Yeah.
Great. So what you're saying is, at this point, because it's conceptual, you can dismiss it because it's not real world. Yeah?
It's, let's say, completely isolating. It aids in the design of engines and refrigeration systems where the expansion of gases play a critical role. It also helps the development of theoretical models to predict the behavior of real gases under various conditions.
So it's got real world application then, hasn't it? Because they use it with refrigerants.
The free expansion of gas itself is not labeled as one of the classical gas laws like Boyle's law, Charles' law, Gay-Lussac's law. I forgot. Yeah, well.
Can I see that? Can I see that citation that you're reading from, please? I want to see that actually says that.
I'm on my iPad, but I'm using my computer to stream it. But I'm looking up the citations on the iPad, so I don't.
If you want to be able
leave
to
the page I'm on.
if you want to, you're able to send me the link in the private chat, then I'll share the screen. It's fine.
Because I don't believe
Yeah.
it says what you just say it said. I think you've made that bit up. You've added it.
Huh? You think I'm lying?
Yeah, I think you're lying. Because the free expansion of gas law is a gas law. It's not conceptual. It's not Mickey Mouse. It's actually science, and they use it real world. I want to see what it says. I want to see that you've not misquoted it and tried to deceive the audience.
I can read it again for you.
No, I want to see it.
If I was making it up, I probably wouldn't be able to read it perfectly again as I read it before.
You can send it to me. Like I said, I'll share the screen. It's fine. Just send me the link in
You
private
could
chat.
just screen share and show us it, or send us the link.
It's on let's say Universal Primer.
Let's see if we can dig this out, Flatzoid. But whilst Flatzoid's doing that, and I'm eating my tea, let's take it a step further, because this is the bit that really screws you, and it really screws our friend in chat called Glenn, because Glenn thinks that if you put a set of scales, he thinks that because the scales show an increase when the pressure's in there, he thinks that that can only ever mean that weight. Okay? And that's consistent with weight. But what I'm going to ask you is, when we're back at the scenario where we've got a single gas molecule, I'm going to stick my weight, or the weight that the scales, I'm going to stick the scales on the ceiling, the up part, right? Tell me, at what point will the scales measure a pressing force against it?
Well, the scales don't usually account for buoyancy.
Yeah, but we've got them upside down on the ceiling.
Which is why you can
down on
hold
the ceiling. Listen, they're upside down on the ceiling inside the container, and at some point there is definitely going to be a force exerted on the surface of the scales, and an increase in pressure will be demonstrated when it's upside down on the ceiling. When is that point?
What?
We've got to. We're back to the single gas molecule inside the container. It's bouncing around freely in all directions off every surface at 600 miles per hour. That's the speed that they claim that the molecules are moving around at. Not my speed. That's the claim, between 400 and 600, depending on the molecule, right? One molecule is bouncing around, ping, 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 and we've got a set of scales upside down on the ceiling, and there's going to be an impact. There's going to be a measured force applying against the scales when it's upside down on the ceiling. When would that point be?
Because of that one molecule of gas.
Yeah, that's why. But when? Tell me when it would be.
I mean, the weight that one molecule of gas would have is like non-existent.
So then there's no weight being pressed against the scales.
It wouldn't really register on a scale.
No, but so then there would be no weight then, because if you're going to say that it wouldn't,
there would be a weight. It would just be neglectable.
Right, negligible. Yeah.
Yeah, that one.
Okay, but there would be a weight though. It would press against it eventually, right? So I want you to tell Glenn in chat, when the scales are upside down on the ceiling, when is the point when it will measure a force? The very, very sensitive ones, the NASA specialists, the 15 billion pounds in, they're very sensitive and they can perceive it. It's measurable. Come on, when will the scales measure a force?
Let's see. Let's see.
And while we wait for instant interlude, I hope you guys are enjoying this. Thank you for everybody that's just joined. Good to see you guys. Hit the likes, share the show. Really do appreciate it.
I've got all night to wait. I don't mind waiting. I'm just
So-
trying to like really quietly eat my tea as well. You can probably hear me, but take your time, Luch. It's fine.
So yeah, it's just the same thing that I said basically. It like gas. Okay, the compared volume making making it more challenging to detect with ordinary scales.
But everything that you just said there was incoherent. I didn't understand any of it.
Oh, okay. So gas does register on a scale.
Yeah.
But
When?
the
When?
weight, but the weight of a gas is often much less than that of a solid or liquid substance of comparable volume, making it more challenging to detect with ordinary scales.
No,
The mass.
these are super sensitive scales. These are from NASA. They cost £25 million, and they're able to measure the negligible impact of a gas molecule against it. Just one. This is not hypothetical. This is real. You can actually buy them. They're super, super sensitive. Right. I want you to tell me, when will the scales measure the force of the molecule, or when will it measure the weight of the molecule when it's hanging upside down from the ceiling of the container? Come on. So really simple. A 5-year-old knows this. You know it, but you just don't want to say it.
Well, take the scuba tank analogy
No.
I made last time.
We'll come to scuba in a minute. We're going to finish this point first, because I'm not happy that you're not answering. We all know that you know the answer, and we all know that you don't want to say it.
What do you want me to say?
I want you to explain to me, when will the scales show that there's a weight to the gas molecule when the scales are upside down on the ceiling? When will it show the weight?
What?
Come on. It's not difficult. You know that we all know that you know the answer, and we all know that you don't want to say it.
What is the answer you're looking for?
Oh, come on. All right, let me change it. Let's go to the basics, and we'll put it on the ground. So now it's on the bottom surface. When will the scales show that there's a weight to the molecule?
What?
We've got a container. It's a cube-shaped container. Yeah. And we've got a molecule bouncing around at high velocity in all directions randomly. And we've just put a set of scales on the floor. They were on the ceiling upside down, but now they're on the floor.
Okay.
Yeah. When will the scales register a weight?
When we put the container on it.
No, there's no container. There's just a single molecule bouncing around in all directions inside the container. Just one molecule.
Yeah, inside the container, right?
Yeah.
So we measure the container.
There's no container. No, the scales are on the inside. We're not going to measure the container. We'll come to that in a minute. We'll deal with scuba tanks in a minute. At this point, we've got the gas molecule bouncing around inside the container in all directions randomly at high velocity. We've now got scales on the bottom of it. It's a very sensitive NASA scales, 50 bazillion pounds, right? When will it measure the weight of the molecule? Tell me. We know that you know the answer.
I mean, there's also the factors to consider, like buoyancy as well.
There's no buoyancy here because there's only one molecule in the thing. There's no medium.
Right.
There's no medium. It's just one molecule bouncing around in all directions freely, as per the gas law, and we've got a scale at the bottom.
So what you're saying is purely hypothetical and theoretical.
No, I'm trying to see if you understand your own argument. I'm trying to steelman your argument for you.
Like, what you're saying is only in theory.
No.
Because there will be buoyancy.
You understand the atomic model, right? Gases are particles.
There's one gas molecule, but there isn't just one gas molecule.
Listen, you understand the atomic model, right? Everything's a particle. Everything's an atom. We've got one gas molecule.
Yeah, It's going
It's
at
bouncing
them.
around freely in all directions inside the vacuum container. And now we stick a set of scales on the bottom. There's only one time when it's going to register a weight for the molecule. We know that you know when that is. We know that you know that we know that you don't want to say so.
When it hits the scale?
Correct. Because you need a force, right?
Okay.
So until it hits the scales, it can't register any measurement on it because it's never it's bouncing near it, but it never hits the scales. And then when it does hit the scales, bang, you get a measurement, and then it's tiny, but it does hit the scales eventually, right? And you'll get a measured weight to that thing, to that molecule, right?
Yeah.
Now we're going to put the molecule on the ceiling again, upside down, on the other surface, opposite. When's it going to measure weight this time?
When it hits the scales again.
Correct. So now we've got the scales on the deck, and we've got the scales upside down. You're saying that atmospheric pressure air's got weight, but you've just measured it. You've just demonstrated how it can be measured in both directions evenly.
Because it has weight?
No, because it's bouncing freely in all directions, and the only time that a set of scales measures weight is when there's an impact. There's got to be a force. But if you put the scales on the floor or on the ceiling, let's put it on like the four sides. When is the set of scales going to measure weight? When it's on all four sides.
So can you use simpler words?
Not really. This is as simple as it gets.
So can you explain what you're saying?
You've just got it right twice. You said when the scales receive the collision, it'll measure a weight, and it was on the floor. You were happy to tell me then. Now we put it upside down, and you've agreed that it's when the scales, when the molecule collides with the scale again. Now we're going to go for the four sides all at once. Any of the four sides, doesn't matter which, but we're going to do it 4 times. When will the scales measure the weight of the molecule? Come on, you've just got it right twice.
When it hits the scales again?
Woohoo! So now we've got direction on all six sides, left, right, up, down, forwards, and backwards. And you're going to still tell me that a set of scales will measure weight because when you put it on the deck, it measures weight. But we've just been through how when you put it upside down on the ceiling and on all 4 sides, it'll still measure weight. But it's not in the downwards direction, is it? It's in all directions. What does this do to your definition
So when a gas molecule bounces around within a container, and at the point where it hits the scale, the scale would measure weight.
Yeah. And if the scale's on any of the surfaces of the cube, it's going to measure weight every time the particle or the gas molecule bounces off it.
Oh,
Only when it bounces off it.
Yeah, you're correct.
Yeah. So scales are not measuring weight, are they? Because they're measuring weight in all directions, not just down.
But this is theoretical, of course.
No, this is practically Okay, so if you don't think it's practical, right? What would happen to that particle if I took the lid off and now it was no longer a vacuum? What would happen to the particle?
It would escape, wouldn't it?
Yeah, obviously. Air would rush in. That particle would leave immediately. You wouldn't know where that particle's gone anymore because it's gone. You're demonstrating that you understand that gas will escape, the molecule will escape, and the pressure from atmosphere will press into that container, the vacuum. You've just also demonstrated how it's not directional because the weight scales measure in all directions, but you're going to tell me that the sky is a vacuum and the pressure that's down at ground level won't press into that vacuum, even though you just demonstrated it right now with us that it will. Has the penny dropped
So,
yet?
pressure and weight.
I'm not feeling
Right.
that you've understood, or if you have understood, you want to change topics. You've just demonstrated how the set of scales will measure weight in all directions, and you've just demonstrated if you took the lid off, that particle would immediately escape, and all air that was in there will press immediately into that container. Yet, you're going to insist that the sky's a vacuum, and that doesn't happen with the Earth.
Yeah, it's theoretical what you say, because over a large surface area, the scales wouldn't pick up any weight. Because there's billions of gas molecules going to be pressing against, going to be like, not like over a large surface area on over that scale, it's going to not really pick up any weight at all, just like how you could hold it underwater and it wouldn't pick up any weight underwater either.
Forgive me, the dog started barking, and you were talking really quietly, and I didn't catch what you said. Just give me one concise sentence for what you just said.
The scale wouldn't pick up, like if you were to hold a scale underneath the water, it wouldn't register weight.
Yeah. Why would that be?
Buoyancy, right?
Hang on. Before we move away from this last point, I want to conclude the last point, because you've just admitted that when you take the lid off, the molecule will escape. The other thing that will happen is all the air that's outside will press into it immediately, right? But you've just explained to me how the weight will be measured in all directions, not just down. And you've also demonstrated how the pressure will press into that vacuum the minute the lid is removed, and that molecule will disappear into space or into the immediate, it'll just vanish from the box. Yeah?
But
I want you to acknowledge that's what you've just said.
Yes, but it's theoretical.
So, then.
No, it's in theory. It is possible.
So how would it be different in real? How would it be different in real world then?
Because we don't really get just one molecule of gas.
But you've just correctly described to me how the atomic model would describe the behavior of one particle in a vacuum chamber, and when you remove the lid. You just correctly described that.
Which is what I said before about it being not what I said before about the let's say.
So then you would agree with me then that the atmospheric pressure is not only in the downwards direction, then it's in all directions.
What I said before, the free expansion of gas itself is not labeled as one of the classical gas laws.
Yeah, I've asked you for the citation for that, and you haven't produced it yet.
That's what I said before.
Yeah, but Fight the Flat Earth says a lot of things that are not right either. And if you can't demonstrate it with citation, Hitchens' razor applies. You've got to support it.
Yeah, like I said, you are able to send me the link. I will be able to share it if you can't.
Because I think you've made that bit up. Where it said it's not an actual gas law, I think you've made that up.
Let's say.
Once you get the citation, then we'll talk about scuba tanks.
I just gotta quickly, while Lou's getting that citation, I have to tell Andy Worth all gas laws, every single gas law in existence, has no gravity taken into account.
Well, actually, the free expansion of gas law states that gravity doesn't affect the molecules of gas anyway. It's too.
That's it. Takes no gravity into account, and I was even given it as a force.
That's why I can give him gravity as a force, because I know that the power of the molecules is so powerful relative to the tiny force of gravity that's supposed to be that it has no effect. I don't think Flatzoid. I don't think he realizes that when he admitted that the molecules will bounce around freely in all directions and only exert a force on the scales when they hit them in all directions. I don't think he realizes what he's admitted to there.
Yep. Luch, unfortunately, you're busy sitting in the same situation where Professor Phil Bell sat with me, where to end up saying, you see that black stuff? That means space. That's all he had.
Because, Luch, I think you've made it up. I think you made that little bit up about how it's conceptual.
No, I definitely have not.
Well, I think you have. But if I'm wrong, I'll apologise, and then we can talk about scuba tanks.
But I would like to see that citation, though, if you don't mind. It's just
No, because
it will be fair.
These.
I mean, before you guys go on the scuba tanks, do you mind if I ask Luch a question?
Yeah, go ahead.
Hang on. I'm worried that if you do ask him a question, he'll take this as an opportunity not to look at the definition.
Okay,
the citation.
You know, I'll type it to you and you can ask it to him.
Oh, yeah, type it to me and I'll ask him in a sec, because I want to give him every opportunity to demonstrate that his claim that the free expansion of gas law or the dual expansion of gas law is conceptual, because I've read that nowhere.
Yeah, I've searched everywhere and I can't find it.
I think he's denying science, the very thing that he thinks that I do.
Nope.
What is it you're doing, Luch? Are you going to send him a link, or are you going to do something different?
Huh.
Okay, I Skyped the question to you, so when you're ready to ask him, you can ask him.
I can't get you the link.
How did you find it? We could do it because all science has got to be repeatable, right? Just show us how you got to the citation, and we'll do it as well, and see if we can get to it too.
It's Flatzoid said that he couldn't find universal primer.
Universal what?
Primer. Yeah, they state they've got an answer for everything.
Universal primer. Right, type in universal primer and then give us the sentence word for word, and then it should come up on a Google search.
Yes. I can send you a photo.
No. All right, send us a photo.
All I can see is when I type in, it brings the University of Michigan up.
Yeah,
and the Guardian, and it's all about the ideal gas law.
Okay, I'll send a photo then. The photo should be.
Yeah,
with the link on it, so we can research it and find it and validate your citation.
That can work.
See. I'll use the computer for this. Actually, I can send it to you on Discord.
Send it to me on Discord.
Yeah.
It's good to see everybody on the YouTube land. Please hit the like, share the show. Really do appreciate you all here.
Here's the quote. So
And then when we get the image, try and validate
what
it.
about the link itself? Let's see.
But it's not bringing up what you need.
It's not letting me.
Why don't you send me the link though? You don't need to send the what?
Yeah, I was going to, but it doesn't work. Oh well, I'll tell you what. You can choose not to believe me. That's fine. I can't get you the link.
Assertions made without evidence can be dismissed without evidence. It's Hitchens' razor, right? If you
Yeah,
can't show
that's
the
fine.
citation,
So you can dismiss my claim. Go ahead.
well, we dismiss
I
your
will
citation.
allow you to
You're not able
dismiss
to.
my claim because I can't show the citation.
All right, but we did agree that the scales would measure a force on all directions of the container when the molecule hits it. Yeah, that in itself
Right.
proves that atmospheric pressure doesn't have weight. Air doesn't have weight. It'll measure it in all directions when you put. We'll deal with scuba tanks in a minute. Flatzoid, asking me a question.
Oh, okay, yeah. I just want to find out: do things like temperature and pressure change the direction of the gas, or does it just change the density of the gas?
The air pressure, difference in air pressure would probably change both, wouldn't it?
Doesn't change
As you
direction.
get-
Gas only changes direction with a collision. That's what's called elastic collisions.
And not temperature.
Temperature changes the density, changes how fast the molecules are moving, but it won't change the direction.
Alright.
I think that's the key you're not catching on. That's why even if gravity was given as a force, it can't change the direction of gas.
Gravity is an acceleration.
No,
No, it's not.
acceleration is caused by gravity, not it is acceleration.
You're misunderstanding the cause and the effect.
What do you think A in F equals MA stands for?
Acceleration.
Yeah.
Yeah,
not gravity.
Gravity. Well, that's not gravity, though, is it? Gravity is the thing that makes. Gravity is the thing that makes something accelerate, not the acceleration itself.
Yeah, gravity is the acceleration in that instance.
It's not.
But
So you're denying Newton's first law of motion, right? Newton's first law of motion states that an object at rest will remain at rest unless acted upon by an unbalanced force. But you're saying, well, something can accelerate without it being gravity. Explain to me how that works for you, because like you think that acceleration is different to a force. Well,
because if F equals ma, so there you go.
But you're applying the second law of motion, which is just a sum, but you're ignoring the first. A lot of you ball earthers do this. You'll ignore the first law of motion and you'll go straight to the second law of motion. But look, the first law of motion states that an object at rest will remain at rest unless acted upon by an unbalanced force. So gravity's got to be a force for it to act on matter, because you say that the sky is being acted on by the force of gravity. It was in the definition.
Gravity creates a force.
No, you can't have something creating it. No, it doesn't. Your Newtonian gravitation that you insist, right? We're giving you Newtonian gravitation, but Newtonian gravitation doesn't cause a force. It is a force.
F equals ma. Therefore,
No, Newton's
if
first
you
law of
have
motion. Newton's first law of motion: an object at rest will remain at rest unless acted upon by an unbalanced force. So, if we see something accelerating, it needs a force to do it, not a sum, a force. Newton's first law doesn't say that you can accelerate mass with a calculation.
It says that if you have an acceleration and you have a mass, you have a force.
Correct. But you're saying that if you've got an acceleration, then you've got gravity.
A is just one part. You also need the mass as well.
Obviously, you need the mass.
Yeah.
If you didn't have a mass, then you wouldn't have anything accelerating. Even if you need the mass.
Yeah, that's
right.
true.
But you're getting the cause and the effect mixed up, because you're saying that gravity is not a cause of the acceleration. You're saying that gravity is the acceleration, because gravity causes a force and some other force does it.
But if you have those two things, you have a force.
Yeah, but gravity is the force that accelerates the mass in your model, not in real world, in your concept.
Gravity. So why can't gravity be the acceleration?
Because that was superseded in 1919, and it goes beyond that. But we're stopping at 1915 at the moment. We're going to give you Newtonian gravitation. But if we're going to give it you, you've got to apply it the way that Newtonian gravitation applies it. And Newtonian gravitation, it relies on the first law of motion, which states that an object at rest will remain at rest unless acted upon by an unbalanced force. And then if you want to, you can calculate the acceleration or the force by doing F equals ma. But you've got to have someone doing it in the first place. You can't say gravity creates itself or gravity creates a force, because the force is supposed to be gravity. If you haven't got a force of gravity, then you haven't got any mass accelerating.
Then we'll use Einstein's then.
No. We're not using Einstein's. You're not up to speed with that. You guys insist that Newtonian gravity. If we were going to use Einstein's, it's way beyond your abilities, right? But Einstein's isn't even an acceleration. It's an apparent acceleration that we perceive, but it's not actually an acceleration. It's caused by the warping of the medium between you and the thing when viewed from trillions of miles away. So it definitely doesn't apply in this situation. You've got to have huge distances for Einstein's for it to even be perceived. But we don't have that on anything on Earth. But let's stick with Newtonian, because we're giving you Newtonian gravitation. Shut up. We're giving you Newtonian gravitation for the purposes of this demonstration or this misunderstanding that you've got. But you're saying that gravity creates a force. It doesn't. Newtonian gravitation is gravity is the force that accelerates mass. So we have the force of gravity accelerating mass. F equals ma is the calculation, but you need the force in the first place.
It's not F equals m times g. It's F equals m times a.
Yeah, because F is the gravity, not the a. The acceleration is not gravity. F is the gravity.
There's no gravity in F equals ma.
I know, but there is an F.
There's an F because of the a.
No, there's an F because of gravity. You're conflating the cause. You're conflating the cause with the effect, and that's what you've been watching too much Fight the Flat Earth. He doesn't understand what gravity is. Actually, he does understand what gravity is. He just can't admit it, and that's why you're confused. You are a product of Fight the Flat Earth and his lies, and we're seeing it right now.
So if I ask Google or something, what is the A in F equals ma? What would
acceleration.
it say?
It'll say it's acceleration. That's why it's
A. It's gravity?
No, it'll say it's an acceleration. The gravity is the F, because you think that Newtonian gravitation still applies, and in Newtonian gravitation, that F that accelerates mass is gravity. That's what the Cavendish experiment's all about. That's not an experiment.
Let's say.
So, in other words, gravity causes a car to accelerate, guys.
Yeah, it just says acceleration.
Notice he's making it easier for you by giving gravity as a force.
But we don't say gravity's a force there.
Yeah, you do.
We say gravity causes a force.
No, that's making shit up. That's not what your rhetoric is. That's what Fight the Flat Earth says, because you can't admit that gravity's not a force.
So
You've been watching too much Fight the Flat Earth, and he's not. Fight the Flat Earth knows gravity's not a force. The problem is you don't know that it's not a force, or you do know, and you just choose to believe Fight the Flat Earth.
does MC2 Nurse say that?
I don't know. I don't watch anything from him.
Oh.
Yeah, all of them say gravity causes gravity, in other words.
So basically, none of them can acknowledge that gravity is not a force because they need it to be a force for their paradigm to work.
Mm-hmm.
So they'll just call it a gravity causes it, but there's no science for that. There's no science for gravity causing a force or gravity being a force. It's been superseded. So there's definitely no science for gravity causes an acceleration or whatever it is that you say.
But has anybody been ever in history been able to show us one thing that causes itself?
So one thing causes itself.
Yeah, so like poofing into existence.
So you guys want gravity to cause gravity. That's what you guys are fighting for.
Yeah, that's exactly what they want. Gravity to cause gravity, but there's no science for this. This is just made up flat earth, ball earth bullshit. And the reason it's made up is because they can't acknowledge that gravity is not a force. They insist on it being a force because they know that they need the sky to be pulled down by a force. But even if we give them the sky being pulled down by a force, we know that air pressure, or what you call atmospheric pressure, is not affected by gravity anyway. So we can give you gravity, it still doesn't cause atmospheric pressure. It's an oxymoron. It's a contradiction in terms.
Acceleration occurs when an external force acts on an object.
Yeah. So you need an external force to act on your gas molecule, right?
Uh-huh.
And we'll give you your external force. We'll give you gravity for the sake of this conversation, right? It's not a force, but we'll give it you for this conversation. The free expansion of gas law, or the dual expansion of gas law, is clearly defined. It tells you everywhere you look that gravity doesn't affect the gas molecules. Why? Because they're highly energetic, full of kinetic energy, bouncing around randomly in all directions with perfectly elastic collisions, and they don't run out of juice.
Can you disprove what I said, though?
I can disprove everything that you've said. Which bit do you think that I need to disprove?
Because the free expansion of a gas itself is not labeled as one of the classical gas laws.
Sorry,
So you're
you
the
had
one.
meant to supply the citation for that. Just have to point that out.
Yeah, you're the one that's citing this document, right? This citation's coming from you, and I say that you're making that up. I don't need to disprove that. You need to prove it first. If I'm wrong, I'll say, do you know what? I was wrong. I was a bit harsh. I shouldn't have said that. I'm sorry. But if you don't prove that your citation says what you said it says, guess what? You're the liar. You're lying to us. You're trying to make people think shit that's not true.
Then how about you ask other people?
I'm asking you, you're citing it. If you're going to cite it, it's on you. So show it. If I'm wrong, I'll apologize, and then we can talk about scuba tanks. But if I'm right, you're lying.
I know I'm not lying.
Yeah, but nobody else does. That's the point. Right? How did you get?
I can't show it. You're lying. I guess I'm lying.
Right, you should be able to direct Flatzoid using the browser on how you got to the document, so he should be able to get to it too. Why can't we do that?
Because it's not It's not on a typical browser.
What browser did you use?
Like what?
Did you use Microsoft Edge? Google? Come on, this is not hard, man.
Let's see. Hold on. Let's see.
Do you know what this stands for here?
This
Luch? Do you know what that stands for there? I guess not.
So I asked him what browser did he use, and he just didn't answer. I mean, it's like there's three that most people use: Firefox, Google, Chrome, and Microsoft Edge. Google. Flatzoid, have you got Google Chrome?
I'm on Google Chrome. This is me in Google Chrome.
What search term did you use, mate? Tell us. Let's just give us word for word the top line. If we search for it word for word, we'll find it. Word for word. Come on.
The top line of
any line. Just do it word for word.
Wait, I got something better. Physics forums. Free expansion of real gas versus Joule-Thomson effect. In summary, two equations can be used to calculate the Joule-Thomson effect as a du CVT, okay? And it's giving all of it as an actual gas law. And this
just
is
tell us, just give us 10 words verbatim and we should find it on that. Come on, 10 words out of that document. Let's give us the 10 words of the bit that you say.
What did you type in
the free expansion of a gas itself is not labeled as one of the classical gas laws?
Perfect. Just all fire and let him type that in.
Not labeled itself as
one of the classical gas laws.
Classical
let's find that.
gas laws.
Because we should. And then what did you say it was the originating website it was on?
Universal
Primer. That's what it says anyway.
You need to be sharing your screen here, Flatzoid. We need to see that you're not being dishonest.
Okay, let me share my screen here. There we go. Typed it exactly.
If you don't want to believe me, that's fine.
The free expansion of gas itself does not label itself as one of the classical gas laws. Okay, this is what it brings up. Okay, I don't see.
It's not that I don't want to believe you. I want you to prove me wrong. I say that you're telling porkies. I'm saying you're lying, and I want you to prove that I'm not right.
You said it's universal what?
Primer.
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 Yeah.
Yep.
But all I can do is it's not letting me do anything with the link. It's just letting me paste.
Can you quickly share screen? There's a thing at the bottom that looks like a little monitor with an arrow. If you click on it, it should give you the option to share screen.
See, when you type in 5 or 6 words that are verbatim in a document, it usually brings up the document. And if you get like 10, it is going to bring up the document, especially when you put the words in from the document.
Oh, I'm using my iPad.
So what?
Yeah. iPad.
If we search it identical to the way that it's written, it will come up. It's just supporting my assertion that you're not telling the truth.
It doesn't even pick up universal primer.
Oh well. I won't use the site anymore then. Let's see. Let's see if I can find it on my own. The free expansion of gas is not labeled as one of the gas laws. The classical gas laws include Boyle's law, Charles' law, Avogadro's hypothesis, Dalton's law of partial pressures, and Amagat's law of partial volumes.
Yeah,
there you
Dalton.
go. It
But that's
doesn't
not
say.
stating. Sorry, but that's not stating the Joule's free expansion of gas law is not a gas law.
It's not a classical gas law.
It is.
Because
It's a
you said it was
thermodynamic gas
conceptual.
law.
You said it was conceptual.
But it's not. It says it doesn't list his name under the classical gas laws.
Yeah, only in that one document. That doesn't mean it's an exhaustive list. Just means that the writer didn't know that one should go in it. It's an omission.
I suppose, maybe. Maybe I'm wrong.
Just because he didn't put it completely in the list doesn't mean that that it's not one. It just means that he didn't put it in the list. It's a list. There's about 10 of them. You know, he's not going to list them every single one. He's going to give the top 3 or 4. Anyway, what we've established is that we're not able to validate your citation. So we can accept that you were lying because you can't show us that you were not.
I suppose so.
Joule experiment on free expansion. Okay, I'm gonna say citation for it. Okay.
Yeah, maybe I'm wrong. Maybe I'm just wrong now. Oh well.
No,
I can
maybe you were
admit when
lying.
I'm wrong.
Maybe you were lying.
In 1843,
No, I'm not lying.
I'm just going to show you how to knot a concept quickly. In
Make it bigger.
1843, Joule did the simple experiment to show that the internal energy of a gas is a function of temperature, independent of pressure or volume. When the gas is left, the sphere initially flows without resistance into the vacuum, the right of the sphere. No work is performed, no heat is transferred, thus the temperature remains constant. It is now understood that this result is accurate only for an ideal gas. There we go.
So let's just do a quick summary. We've concluded 2 points so far. We've concluded that if you put a set of scales on all 6 sides of a cube vacuum, only when the molecule hits the scales will a force be registered and therefore demonstrate its weight. But it does it in all 6 directions, left, right, forwards, backwards, up and down, not just down. That doesn't bode well for atmospheric pressure, having weight, because it presses equally in all directions when you correctly applied the atomic model. So that was the first point.
So since it presses equally... never mind, go on.
The second point we concluded was that you cited a document and gave a citation, gave a reading from it, and I called you on it, and you were unable to demonstrate that what you were citing from was truthful and accurate. That's the second point.
I gave you a quote.
No, it's unverifiable, isn't it? We're not able to test it to make sure. We're not able to check it to make sure that you're not telling porkies. I think you added that last line all by yourself because you don't want it to be a gas law. You want it to be a hypothetical or a theoretical one.
But go on.
Well, that's 2 points that we've established, right? Now let's talk about scuba tanks. What is your point with scuba tanks?
That if you fill up a scuba tank with gas, it'll have more weight than it did before.
Okay, so would you agree that you need the container to do that in the first place? With no scuba tank, there can be no measurement at all. Would you agree with that?
Yeah.
So there's got to be a container, right? That's the first concession.
Well, for you to be able to measure it, yeah.
Right. Okay. Great. So we agree that there's got to be a container for this thing to work, right? So we get a container, we get a scuba tank, and it weighs 10 kilograms when it's empty. Stick it on the scale. It shows measures 10 kilograms. Then we fill it up to its full. Tell me what then happens.
It'll increase the weight.
Right, it increased. Now, so a scuba tank that's now got lots and lots of molecules in it, bouncing randomly in all directions, and we've just demonstrated with one how it works. But now you've got billions upon billions upon billions, and they're all bouncing in all directions, not just down. But you've got a set of scales on the outside, and you're measuring it only in the one direction. But you've demonstrated to us before that when you put it on the left, on the right, on the upside down, on the top, that also measures a weight. So you're doing it again now externally, but you know that it measures weight in all directions because you just taught me through how it does.
Oh,
what does that do to your claim that gas has got weight?
You got me.
That's only one way. There's another way I've got you as well.
What's that?
So we've got a gas, we've got a container, and it weighs 10 kilograms. We fill it up with gas, and now we're going to acknowledge that it now weighs some other number that's not 10. So let's just say it could be 11, just for argument's sake. And you're going to say, if you minus the 11 from the 10, you get 1 kilogram. Therefore, gas equals 1 kilogram. Correct?
The amount of gas that's in there, yeah, it would be 1 kilogram of gas.
Yeah. Is that a measurement or is that a calculation?
It would be a measurement, right?
No, that's a calculation.
Oh, so you calculated the 11 minus, yeah.
Yeah. So you've not measured
10.
You haven't measured the weight of. You haven't measured the weight of the gas, have you? You've calculated the weight of the gas.
But now, then you measured it.
No, you haven't measured it. You've only ever calculated it. And what you've done by calculating it.
Scale.
What you've done by
calculating it, it's weighing 11.
You've measured
then you did some calculation.
Hang on.
Find out how much gas is in it.
You just said you've measured it weighing 11. What's it in this in your sentence?
The container filled with gas.
So we're measuring the container plus the gas that's inside the container equaling 11. We've not measured the gas inside the container, have we? We've measured the container and the gas, correct? So the only way that you can deduce.
So if we release the gas and the number lowers, we can estimate that we've got 6 kilograms of gas in there.
The only way,
if the container by itself was 4 or something.
The only way that you can make the statement that the gas weighs 1 kilograms is if you perform a sum, because we can both agree that if you remove the container and just weigh the gas alone, it's going to expand freely in all directions, and you're not going to be able to weigh it. So you need the container, and then you're going to perform a sum. And you're going to make the assumption that gas, therefore, can be measured or weighed by executing the function of the sum, not by measuring it. So you haven't demonstrated that gas has got weight. All you've done is performed a function, a sum. That's all you've done. That's not showing that gas has got weight.
No.
Yeah. You haven't measured weight. No.
Because
you haven't measured weight.
One, we measured it without gas, and one, we measured it with gas.
Yeah,
and the numbers were different.
In both instances, you've measured the container as well.
Yeah.
So you've not measured the gas. You've measured the gas plus the weight of the gas. Sorry, in the second instance, you've measured the container and the gas that you put in it, and it measured an extra kilogram. So you're going to now do a sum where you say, this is the weight before, this is the weight after. Take one from the other, and then gas has got weight. No. Because you haven't got weight, you haven't measured weight. You've calculated weight because you've took one number from the other, but you can't measure weight because you're not going to be able to measure it. It's going to expand freely in all directions immediately. You're not going to be able to measure the weight
in the container.
Pardon?
Unless it's in the container.
Unless it's in the container. What do you mean?
Like you can. would you agree that if you put something in a container and then the container weighs more than it did before, that what you put in has weight?
No, because we've just been through how it expands freely in all directions, and we've just been through how weight is only in the downwards direction towards the center of Earth. So no, I don't agree with that. It's just your misunderstandings. It's
I
just your
do.
misunderstandings because you've been told that if you get a scuba tank, put gas in it, and then weigh it and take one from the other, then you can say gas has got weight. No, we've just
Then we
been
can
through how
say,
gas expands freely in all directions, and you must have a container to make it look like it's got weight, because if you didn't have a container, it'd disappear freely in all directions. Yet you want us to believe that the sky is a vacuum, in total violation of the very rule that we've just agreed, and you've demonstrated for us that you understood. You're trying to get us to believe a contradiction in
the sky is a
terms.
vacuum?
Pardon?
The sky is a vacuum?
Yeah. You guys believe that the sky is a vacuum.
But it's not.
So what's the sky then if it's not a vacuum?
It's not, because it has stuff in it, right? So it's not a vacuum.
Yeah, but you guys tell us that as you gain elevation, the density or the pressure gradient decreases and decreases and decreases.
Yeah.
Yeah. Now, by definition, any variation, significant variation in pressure change, by definition, is a vacuum. Now, you can argue semantically whether it's half of 1 psi, a quarter of a psi, a tenth of a psi. I don't really care what value you give. But you guys definitely tell us that as we gain elevation, there is a reduction in pressure.
Yeah.
So, and the higher you go, eventually you end up in deep space. You go beyond the so-called Kármán line. You get into deep space. I don't care where you tell me that the space begins, but it's definitely a change in pressure. And by definition, if there is a significant change in pressure, you have a vacuum. It doesn't have to be zero. It doesn't have to be very close to zero. It just needs to be 2 or 3 degrees, 5 degrees, 7 degrees, 10. I don't care what value you put to it, but we're definitely getting to it as you climb a mountain. Yet you believe
it's not a perfect vacuum.
Right, but it is a differential though. And it's the strongest. It is the biggest differential known to man, according to you and your model. So much so that even the Sandusky, Ohio vacuum chamber can only get halfway towards its the claimed pressure difference in deep space. Because instead of getting 10 to the minus 17 torr, it gets, 10 to the minus, I think, 8 or 9. It's about halfway numerically between what you tell us is deep space. They can't create it. But the thing is, if you could have gas pressure in a vacuum, you wouldn't even need the concrete-walled Sandusky, Ohio chamber. You would just be able to create it. There would be no chamber required. But they've got to have a 10-foot thick or 20-foot thick concrete wall reinforced with steel to try and create that vacuum differential. Yet on Earth, there is no barrier, according to you guys. It just disperses over distance.
We have gravity.
Yeah, even if we give you gravity, it doesn't act on gas molecules. There is no change in direction caused by gravity with gas molecules.
But there isn't there?
No. Even if there was, the gas pressure would still press into the available volume. Have you heard the formula PV equals nRT?
PV equals what?
PV equals nRT. I would think that Fight the Flat Earth would cite this quite a lot.
Ideal gas law.
What's that one?
It's a gas formula to describe the behavior of gas in a volume. You can predict the volume.
That one.
PV equals nRT. It doesn't matter if you've not heard it before, because Fight the Flat Earth doesn't like talking about it. I can understand why you wouldn't talk about it, because the PV equals nRT, the V bit stands for volume. If you have PV equals nRT with the infinite volume of space that is continuously expanding, according to you, you don't have any volume. You've essentially got a zero value. So when you do any function, any sum, any formula, any arithmetic at all, and you multiply by V, and that V is 0, immediately you have a 0 value, which if the sky was a vacuum, that zero value would mean that we can't breathe if the sky was a vacuum, because there is no volume. It's infinite. It's zero. So I can understand why he doesn't like talking about it, but you should know about it, because PV equals nRT is, well, you would probably call it conceptual, but it is part of your official narrative. It's physics. So let's get back to the scuba tanks. Let's conclude this point.
I was gonna.
No, we're going to conclude this point, and then we can move. We can go to somewhere else if you want. Scuba tanks. It weighs 10 kilograms when it's on the scales. You fill it with gas. It now weighs 11 kilograms just for the sake of this demonstration, right? You then say, well, it's 1 kilogram, obviously, duh. And we say, you're not measuring the weight, mate. You're calculating the weight. And the only way that you can do that is with a container. Otherwise, your calculation doesn't even work.
Calculating it.
Pardon?
We're calculating how many kilograms of weight the gas has.
But you taught
or how
me through
many kilograms we've added.
But you taught me through before how the one molecule bouncing randomly in all directions inside the cube of a vacuum will press it against all 6 walls of the vacuum. And when you put scales on it, when the molecule collides with the scales, then a pressure will be measured, and that will be interpreted to be weight according to you. Yes, so when you put your gas inside that container, that scuba cylinder, it's going to be bouncing randomly in all directions, not just down.
But remember, that's theoretical.
Doesn't matter. It's not right. Okay, so then you don't like that. So in that case, then what's happening to the gas molecules that are inside the container, inside the scuba tank? Not theoretically, actually.
If you filled it to the brim, they wouldn't be moving.
So they become a solid. Really? Is that what you think?
Not a solid, but they wouldn't move.
Yeah, they would.
No, because there's gas in the way. How are they going to move when there's gas in the way?
They bounce off them. They're all moving randomly in all directions. They're not in the way.
Not if it's filled to the brim.
Sorry.
No, you seem to be treating gas molecules as liquids or solids. They're not like that.
That's the thing. Is gas compressible, Luch?
I'd imagine that maybe.
Yeah, they are. But you're treating them as though they're liquids or solids. But gas molecules don't behave like that. That's why we have gas laws. They flow randomly in all directions.
In this situation, they could be treated as liquids and solids.
Yeah, but they're not, though. In real world, they're not. In scuba tanks, they're not. They're still randomly bouncing off each other at high volume, at high velocity, freely in all directions. There's just more of them. It means they're not moving down, mate. There's not a weight to them. Even if you accept the container point, which we don't. We say you're calculating weight and assuming it.
Let's say.
Come on, what are you thinking?
I was gonna... When we first... What we talked about before, when you place an object in a gas chamber and it becomes more... what was it? Heavy?
Well, we can come to that in a minute.
That's what we talked about last time.
Yeah, we're going to come to that in a minute. We can go. I'd forgotten. I'll be honest. I did forget about that completely. But we will come to that in a minute. But we're going to close this point off first. So let's finish scuba tanks, because you guys like to cite scuba tanks. So I want you to tell me how calculation is not measurement, because you seem to think it is. So tell me how I've got it wrong, and then tell me that when you measure the tank with the gas in it, how that's measuring weight when you demonstrate earlier that the gas molecules bounce around freely in all directions. What that means is, if you were to put the scales on the side or on the top, it would still measure a weight. There would be an increase in pressure pressing against it in all directions because of the behavior of gas. It's the same as a helium balloon. Have you seen those inflatable sharks that float around rooms?
Sharks that float around rooms?
Yeah, they're basically like toys for kids. They're like hot air balloons, but on a small scale for children to play with. They've got remote controls with them, and they can pilot them around the house. And it's basically a blimp floating around the house. But some of them look like sharks. Some of them look like planes. Some of them look like cartoon characters. It's novel. It's a toy, but it makes a really, really important point that you seem to misunderstand. The pressure inside of them. Flatzoid, try and get that video up from. I'm just trying to remember where it is. Do you know the one I mean? Where the animals are flying around there you go. Can you see the mega flyers that he's showing here? Can you see what he's got on screen?
Hold on. Yeah. Okay, what we got? Oh, fish. Oh,
no, it's a balloon.
Oh, it's a balloon.
Yeah, it's a balloon. It's a toy for kids. But it's really relevant to this topic, right? Because the gas molecules that are inside that shark, right? Explain to me what they're doing. Are they pressing in a downwards direction? Or are they moving randomly in all directions inside?
What gases in there?
Doesn't matter what gas it is. They all behave the same way.
Well, helium would go up.
Right. It's obviously not helium, is it? Because it's not going up. It doesn't matter what gas it is. Just tell me what's going on inside the shark. Are the gas molecules pressing down, or are they pressing randomly in all directions, as we've just described before?
I'm not sure.
You do. You told it me before. When we had one molecule, it bounced randomly off all the sides of the container. We had that conversation first. But now we've got thousands and billions of them, right? And they're all doing what inside the shark? Come on. You know this.
Well, do you want to hear me say that they're bouncing around in all directions?
No, I want you to tell me what you think they're doing. It's not a gotcha. It's not a gotcha. The next question is, but this one's not.
Oh. So they'd be bouncing around in all directions, right?
Yeah. Now tell me what the gas molecules are doing around the outside of it. Not on the inside of the shark. The ones on the outside of the shark. What are they doing?
Pressing down on it.
No, they're doing the same thing as what's on the inside of the shark. They're moving around randomly in all directions. Have you ever heard of Brownian motion? Do you know what Brownian motion is?
Do you know what happens when you let go of a ball underwater?
Yeah.
Like a golf ball or something? It'll float.
Listen, let's come to it in a minute. Do you know what Brownian motion is?
No, it'll float, right? In the way.
No.
Gas
let's come to that in a minute.
The same as water.
Stop. We'll come to that in a minute. Hold fire. You can do this. You can lead in a minute. Let's close this point off with the balloons. Do you know what Brownian motion is? Yes or no?
No. What's that?
Right. Brownian motion is basically where that shark is suspended within its medium and it's floating. It's neither going up nor down. It's sat there and it's not moving in any direction because he's not asking it to. It's just floating in its medium, right? Brownian motion is the behavior of the gas molecules on the outside that are randomly hitting it in all directions in 360 degrees, not from the top to the bottom, in all directions. Now that shark the shark is subject to Brownian motion when it's not being accelerated by the remote control, when it's just sat there. There's loads of demonstrations of this. You can see it everywhere online. There's balloons that are not moving and stuff. But it's subject to Brownian motion. The very fact that Brownian motion exists debunks the notion that there's a downwards acceleration to air. Because if there was a downwards acceleration to air, Brownian motion couldn't exist because it wouldn't be random in all directions. It would be directional with respect to gravity in the center of Earth. But Brownian motion doesn't reference the center of Earth in its definition. Brownian motion says clearly it's random in all directions all of the time. But you've never heard of it, so we can't really explain it any further than that. So we'll just have to unless you want to bring it up. Oh, yeah, he's bringing it up now. He's bringing it up on screen. Can you see on screen?
Mm-hmm.
He's going to show how these molecules in this example. I've never seen this video before, so I'm not really... Oh, randomly. The keyword random. Not directional. Not down. Not down. I don't know what this is saying here, so I've never seen it. It's showing how
supported
it's going to be
by
random.
a fluid. In this case, that fluid is a gas. You are unable to see the gas particles directly because they are too small, but you can see the larger dust particles. The reason that the dust particles move randomly are because of the gas. We know that the gas is there because every time we move our hand through the air, we feel them against our hand.
Mm-hmm.
So not down then. Randomly in all directions, but you can see I've never seen this video before. It's the first time I've seen it. But he's saying that you can see the dust particles and they're moving randomly in all directions. You've been into your loft space before in your house and you found a little beam of light coming through a little tiny hole, and you see that the molecules, the gas, the dust molecules are all randomly moving in no particular direction, but they're all moving. You've seen that. You must have seen that in your house, right?
Well, gas molecules moving.
No, the dust particles. That video is making video is making the point that the dust particles are moving freely in all directions. But you can see this yourself. On a sunny day, go into your loft space and find a hole in the roof, a little hole somewhere, and there'll be a beam of light. And you can see the dust particles are catching the light to your eye, and you can see that they're randomly moving in all directions. If there was a downwards direction to gas, to the atmospheric pressure that we're breathing, all of the molecules would have a directionality towards the ground. They can't be moving randomly in all directions, but in real world, they actually do. So now my question is, which one's conceptual? Atmospheric pressure or real world demonstration where you can see yourself that the molecules are moving freely in all directions, immediately debunking the notion that atmospheric pressure is a downwards directionality of gas, and therefore the air that we breathe.
Other forces exist, so
like what?
Like wind.
Yeah. So when we see wind blowing these molecules, you can see it. No one disputes wind.
That move. That appear to move randomly in all directions.
Yeah. But no one disputes that wind exists, though, right? Everyone acknowledges that wind exists. That's like Bev when he says that the ground is measured to be... He's measured elevation variations in the ground, so therefore the Earth's not flat. Yeah, no one disputes that. Well, no one disputes that wind exists either. So that's not in a contentious position. But if wind didn't exist and you were saying, oh, well, look at the behavior of these molecules, they're all going in an easterly direction. I wonder what might be causing that easterly direction. Maybe there's something called wind. And we would say, nah, it's a pressure, it's an attractive force to the east. And we're going to call it eastity. You couldn't prove or disprove it either way. You just see the effect. But the problem that you've got in this case is that we don't even see the effect of a downwards directionality. But you insist that there's something acting on it, but we don't even see it.
Oh, let's imagine that there is only gravity. Then,
yeah,
that gravity is the only thing.
Then we would see evidence of it.
The gas.
We would see evidence of it because all directionality would always be in the downwards direction with dust particles. They would never move randomly in all directions.
Because of buoyancy as well.
No, but you just said that there was only gravity. So buoyancy doesn't exist.
Buoyancy is part of gravity. So.
All right, but that doesn't explain lateral motion in all directions, not just up and down, all directions. And we see that. We see that in the attic space, your own house.
Yeah, because there's gonna be some external force acting on it.
Okay. Well, like what? In your attic space, what other external forces can there possibly be? There's no wind. There's no love. What other forces might there be?
Just... I'll look it up. Like
they move randomly in all directions, mate. There is no directionality to it. If there was, you could come up with some hypothesis, perhaps, for what might be causing it, but they move randomly in all directions. That's why we can't really inhale too many of them, because they're moving in all directions. You don't want to start playing around in the attic space too much, do you? Because you're going to get dust particles everywhere and you're going to be inhaling them. But if there was a downwards directionality, they would fall back to the ground straight away, wouldn't they? But they don't do that. Have you got a real burning fire in your house, or have you got a gas fire, or what?
We've got a gas stove.
Fireplace. What fireplace have you got? Any fireplace or not?
We don't have a fireplace.
Right. Okay. So I can't use this example either. All right. So now, what was the one that you wanted to talk about? Remind me.
What we talked about before.
Remind me.
Oh, what? How you wanted an explanation about why things get heavier in a vacuum chamber.
That's right. So we had an object, an inanimate object. It doesn't matter what it is, just not a football. I was watching the football that day, and that's why I came up with trophy and football, because I couldn't think of anything quickly off the top of my head. But we've got an inanimate object. It's a concrete figurine of some kind. It's some kind of bust or a little lion. It's a concrete lion. And we put it in a vacuum chamber, and then we evacuate the gas. We can observe that the concrete lion reduces its mass. But you say that atmospheric pressure presses down on it with a vertical column of air pressing down on it, because that's what the definition says. And I said to you, here's a demonstration that shows that it doesn't do what you expect it to do, because you would expect, if you remove that downwards acceleration, that it would get lighter. But what it actually does in real world is it gets heavier, contrary to your claim that atmospheric pressure has weight. Because if atmospheric pressure did have weight and you remove that weight, the object would get lighter. I asked you for an explanation for this. Did you get one?
My simple answer would be buoyancy. Buoyancy. Yeah.
Is that it? Have you got a more complex answer than just one word?
Yep. Here we go. Let's say when you place an object in a vacuum chamber, it does not actually become heavy in terms of gaining mass or experiencing more gravitational pull. The perceived increase in weight when measured on a scale inside a vacuum chamber compared to in air is due to the elimination of buoyant force that the object experiences in the air.
So buoyant force is an upwards force, but you're telling me that the air has got a downwards force. So which is it? Is it that the air's got a downwards force, or is it that it's got an upwards force?
It's just when you have air heavier than other air, that air gets pushed up.
Yeah,
the lighter air gets pushed upward because the heavier air gets pushed downward, forcing the lighter air upward.
So which is it then? Because you seem to be contradicting yourself. On the one hand, you're saying that there's air that gets pushed up, and on the other hand, you're saying there's air that gets pushed down. But it's not supposed to be that as per your definition. Yeah, but you say that atmospheric pressure presses down. Your definition says that the air presses down. It doesn't say anything about anything pressing up.
Buoyancy. But buoyancy would be it pressing upwards.
Actually, what you're describing is displacement. You're not describing buoyancy. You're calling it buoyancy, but it's actually displacement. We can demonstrate displacement. We can demonstrate something rising up because something else around it's got more heavy. You would call it buoyancy, but actually the cause is demonstrably varying the density of the medium.
No.
Have you seen the egg test that everyone tries to laugh at me about, but they only apply laughter because it's really devastating to their nonsense? Have you seen it?
Because you added salt to the water.
Yeah.
Which changed buoyancy.
No, I added salt. Salt doesn't make stuff more buoyant. It makes it more salty. And when it's more salty, you're adding mass to the medium, aren't you? You're not removing mass.
Can I give one word there that it's actually showing? because I did it with the orange as well. Displacement.
Yeah, we'll come to the orange in a sec. So, right. So, when I added the salt, I added more salt into the medium. When you add more salt into the medium, the mass of that medium increases. Would you agree? The mass goes up.
So, yeah. Wait,
Right.
what did you say?
When I added salt into that medium, the mass of that medium, the density of that medium increased. The volume didn't increase, but the density did, because mass increased.
Yeah.
Yeah. So if I increase the density of the mass, right, and bearing in mind that an egg and the salt or the medium that the salt is in, the egg and the salt cannot occupy the same space. One's got to give way to the other for whatever reason. But if I then give it a reason to give way, and it does give way, then the thing that I just did, by definition, scientifically, is the cause. I put 10 definitions.
Guess
What?
Density is also part of the buoyant force.
Yeah, but right. So density is part of the buoyant force. You're going to give me a mathematical explanation here, aren't you? You're not going to give me a practical explanation. You're going to give me another sum, essentially, right?
Like a formula, right?
Yeah. So sums don't do anything. It doesn't say in Newton's first law of motion that you can make mass accelerate by applying a sum. It says you've got to apply a force. You people are obsessed with you people are obsessed with replacing actual real world demonstration with calculation instead, which is the reason why you cite the scuba tanks, because you want to calculate weight. You don't want to measure weight because you know that you can't measure weight of air because it expands freely in all directions. So what you want to do instead is you want to measure it inside a container and then pretend that the container wasn't there for the purposes of the measurement that you got, and then insist that because you can calculate it, therefore air has got weight. That's all you want to do. You want to replace you want to replace demonstration with calculation. But Newton's first law states clearly that if you want to cause an acceleration of a matter, so in my case it was the egg, you've got to apply a force, right? Scientific method states that's why I put it 10 times in the video. It's the thing that is deliberately manipulated by the researcher. And that's 10 times I put it in the video, so there can be no ambiguity. And the thing that I varied was how much salt was in the water, because I put a bit more salt in it. So I'm definitely changing the concentration of salt in that water. And the egg accelerated.
Well, yeah, you've displacement.
Yeah.
Would be the V, right? The volume.
No. Displacement is the force that caused the egg to move, right? And it was from the underside because the salt is more dense than the medium that I was putting it in. You saw the egg pass past it. The egg didn't accelerate until the salt went past it. When the salt was above it, there was no acceleration. But when the salt went below
the V in buoyancy would be the volume of the fluid displaced by the object, right?
Yeah, but again, you're applying a sum. We don't do sums to cause acceleration. All you're doing is calculating into existence your just so story.
Oh, no. We can use the sums.
No. The definition of the independent variable does not say a calculation. And all you want to now do is calculate your force into existence.
So you want to know what the independent variable for buoyancy is?
There is no independent variable for buoyancy. You can't cause buoyant force. It doesn't exist.
What? The buoyant force doesn't exist?
No. Because to get buoyant force, you need gravity to be a force.
Let's see. What is the independent variable for buoyancy?
Buoyancy is... There is no independent variable for buoyancy. You can't vary and manipulate gravity, because even if it was a force, how would you actually do it? You would have to massively increase the size or the mass of the Earth, and you'd have to vary it. So you'd have to have like some at the size of the moon. Earth would have to shrink down to the size of the moon, go up to the size of Jupiter, and that was supposed to vary the gravitational force.
Now look, here's what you did with the salt and the egg. Changing the density of the fluid can affect the buoyant force on an object submerged in it.
But we know that buoyant force...
For example, salt can be added to water to increase its density, and the effect of the buoyancy of objects can be observed.
Yeah, the effect of buoyancy doesn't exist. It needs gravity to be a thing in the first place, otherwise there can be no buoyancy. It's like saying you can have a rump steak or a sirloin steak, but not have a cow. If cows didn't exist, you couldn't have rump or sirloin steak, could you?
No.
Right. So if gravity doesn't exist, you can't have buoyancy either. Gravity's got to exist as a force for you to have buoyancy.
Well, good thing it does exist.
Yeah, it doesn't. I know you think it does, but it doesn't. It's not the current position in science. I know you think it is, but that doesn't make it true.
Gravity, we can observe the mass's attraction.
No, we don't. There is no such thing as mass attracting mass. We don't see this in real world. I know you say that we see it, but we don't see it, because if it did, all objects would have to be attracted to the huge mass of Earth. They're not. Some objects go up.
It only generates an acceleration of 9.8 meters per second squared. That 9.8 meters per second squared isn't really that powerful. We can jump.
9.8 meters per second squared is not a force. It's just a measurement of an acceleration.
We can jump to get away.
It's not even a measurement of an acceleration. It's a calculation of an acceleration. Mathematically demonstrated, but that's not making it things accelerate.
Well, what about the Cavendish experiment then? That's not mass attracts mass.
Right. First off, it's not an experiment. And secondly, it's been replaced.
But no.
What? But no, did you just say?
Yeah.
It's been replaced, mate.
No.
Right. If the Cavendish experiment was true, then do you know what year it was done? First off.
What has the Earth done?
Do you know what year the Cavendish experiment was done? Yes or no?
18. I don't know. What year was it done?
1837, was it? Do you want to look it up? I can't remember off the top of my head. It's been that long since I've looked it up.
Yeah, me too.
Could you look it up for me, Flatzoid, please?
Let me quickly get it for you. Already got it on the citation. There we go. 1798.
Okay, so just call it 1800, right? Right.
Okay.
So in 1800, the Cavendish experiment was completed, but in 1915, it was the whole theory of Newtonian gravitation was replaced by Einstein. If the Cavendish non-experiment was true, legitimate, validatable, it would immediately debunk Einstein, and it would never. Einstein's theory of general relativity could never come into existence because it would be superseded already by the existing science, the current position.
Why? In other words, one's been able to debunk F equals ma.
It doesn't happen in the first place. Mass doesn't attract mass. It's a fraud.
But it does.
It doesn't.
It's an apparent attraction.
It's not. It's supposed to be an actual attraction, not an apparent attraction. Because apparent attractions don't cause accelerations. They cause apparent accelerations. What we do see, according to what your model tells us, we do see an actual acceleration. So it has to be an actual force.
Einstein would say it's an apparent attraction.
Yeah, and he's the current science, right? So what does that then do to the previous position?
Well, it hasn't been debunked.
It replaced it, mate. That's what superseded means.
But
Right,
not
so
debunked it.
see this. Can you see his screen now? Flatzoid showing something that I did. Well, I didn't do it. It was Dr. John, and a few other people. But what we were trying to do was to see, could we get the phenomena in the first place? We were trying to see whether mass attracted mass. And we did this for months. We were trying to validate the claim that mass attracts mass, right? We're not bothered about by how much. We're not trying to calculate the density of Earth. We're just trying to see, can we get mass to attract mass? And no matter what we tried. What?
Wait, did it work?
No, not at all. It behaved totally erratically. We had it set up in a garage, and we had it set up in an isolated chamber, and it was statically isolated. It's wrapped in tin foil, and then it was earthed out, so that if there was any static, that charge potential would be discharged elsewhere. And it was done in a garage so that children couldn't come in and disturb it, or like how what's his name, Hillbilly Blue Balls, how he was shuffling around in his garage whilst he was claiming to demonstrate that mass attracted mass. Yeah, you can't be in the place while it's being done, because your presence causes disturbance of air. That's why Cavendish did it with a telescope outside the room. But we had it all set up. If you go to any of the other videos in that playlist, we have no explanation for why it was behaving the way it was. But sometimes it'd be sat stationary, and then other times it'd rev like a rev counter on a car, and it'd start spinning randomly in all directions, not just one way or the other.
Well, and you go away from the thing.
Yeah, it'll go forwards, backwards, and it'll do it randomly. It'll do it when there's no sun. It'll do it when the sun. It's as if there was something else interfering with it, ghosts or whatever. I don't know what it was. We don't know what it was. We couldn't. But the point we were trying to prove is, could we demonstrate that mass attracted mass? And it was that sensitive that there were other things that were causing it to accelerate randomly in all directions. So the conclusion we came to,
it is pretty sensitive.
It's very, very, very sensitive, right? See, we've got here a big container full of water, or a big container. I think it's coolant. I think it's engine coolant, or screen wash. I think it was screen wash. But
there
anyway,
literally has to be nothing in the room with it.
No, because we're trying to create mass attracting mass. We're trying to get mass right next to it so that the mass is attracting the mass.
To be able to observe it. Wait, was it hung by a string?
Yeah, so you're looking down on a big mixing bowl, a big steel mixing bowl, and it's got a see-through lid, and he's got a drain pipe connected to it with your twine in it. And we use different twines because they've got different torsion amounts, and some of them are not sensitive, and some of them are so sensitive. But the point is, we were trying to, could we show that mass attracted mass? So when we're putting a weight next to it, we're expecting that to be the weight that's on the bar to be drawn towards it. And then when it goes past it, it'll stop and then go back the way it's just come. Because that's what the effect is that you guys claim is mass attracting mass.
You'd need to wait at least a day.
Yeah, we were doing it every night, overnight, every night. It was like 9 hours, 10 hours, 12 hours.
But you'd have to make sure that no twist is in the string or something.
Yeah, I understand. But Hillbilly Blue Balls was able to demonstrate it immediately. He was able to manipulate it straight away and show it perfectly. So if he's able to do that, we've got to be able to do it too, because science is all about repeatability, right?
If you have like a physics degree.
Yeah, look at this one. Look at this one here now. Look at the time. It's 3:30 in the morning, and the weights are coming and going, but they're not relative to the weights that we've put. They're acting all by themselves as if the weights are in a different position. Now, they're not magnets. These are just weights, heavy weights. Now, whatever's going on with this, right, we're all in bed. And this is a time-lapse. This is a time-lapse camera setup. So it takes a picture every X amount of seconds. So we can see what it does in like 20 seconds worth of footage over the whole night. And we can see, is it moving? And it's moving all by itself. But it's not moving relative to the weights. It's moving randomly by itself. And we have no explanation for it. So we were asking you anti-flat earthers, what are we doing wrong? Oh, you got to change the wire. And see how far it went then. But whatever's going on here, this is totally inconsistent, because it should settle pointing at the weight, because that's the point where the mass would attract mass the most. So it should act like a pendulum where it runs out of energy and gets to a point that is zero, which should line up with the weights. But it's doing
That's
stuff all
not
by
how
itself.
that's not the ideal place to do it.
No, of course. It's very easy for you to say that. But when we played with it for months trying to rule out all of the things that we think might be affecting it, we were unable to get it. We were unable to cause the effect that you say, which is mass attracting mass.
The way people
But I'll
do
ask
it
you
all
a
the
question.
time.
If I may ask a question, if you say that's not the right place to do it, if it's in an isolated garage, why do you guys claim they do it in classrooms full of students?
Yeah.
They don't.
Yeah, they do.
It would be like impossible to get it to work in a place full of people.
Yeah, but that's what they show us online. Is for this video showing a teacher in a classroom full of kids, and he uses bowling balls, and he's got them moving these weights around, and all the kids are sat there giggling. Don't forget the kids are adding temperature to the room, and they're all moving around. He's moving around and all that. Yeah, that's supposed to be a claim of mass attracting mass. Yet when we put it in the most controlled environment that we could possibly create, and it acts all by itself independently as if there's ghosts in the room, and we have no idea why it's doing it. The whole point is that we're supposed to repeat it, and it should work. And we couldn't even get the phenomenon. No, it's in an isolated chamber. There's no wind in there whatsoever. It's in the dark. This is an infrared camera, infrared digital camera. It's dark. There's no sunlight. There's no drafts. It's shut. There's no kids running around. It's basically static. Nothing's moving. Yet something's causing this to accelerate randomly in all directions, and we have no idea what it is.
Now.
What?
It seems to have settled down now. It's not moving.
Yeah, and I think this time is when the weights were removed to see when it was, what would it do without the weights there, and it still behaved the same way as if the weights were having no effect whatsoever on it. I mean, I don't know specifically what happened on. I don't know specifically in this particular video what was going on, because I'd have to look at what was.
Yeah, you added the weights again and that moved away from the weights. The weights was taken away. And it's settled down. As soon as you put the weights there, it moved away.
What material is this?
What material?
Is it metal?
Yeah, lead weights, lead balls, on like what Cavendish did.
What is that? What got placed next to it?
Weights, big heavy lead weights. We used the heaviest weights that we could find.
Away.
These weights here are not the heaviest weights that we used. We ended up using rolls of lead that you use on buildings, you know, like lead flashing, because they're like mega heavy. They're dead expensive. They're mega heavy, 100 quid. And they're not cheap. But we bought it to see the heaviest, most dense object that we could find. Did it affect the way that it behaved? And it didn't. It had no effect on it whatsoever. It randomly moved at different times of the night for no reason whatsoever that we could see.
That weight that you added next to it seems to be pushing it away.
Supposed to be attracting it, though, isn't it? You say that mass attracts mass, not repels mass.
It seems to be doing something weird when you add that weight next to it.
But it did the same without the weight as well.
Is the weight like a magnet or something?
I think what he's showing on this is that I think he's showing this weight is not meant to be magnetic, but it seems to be affecting a compass, but it's not supposed to be magnetic. It's not a magnet. From what I remember from this isn't a magnet. This is just a piece of metal.
Yeah, and you guys used different weights as well, and it gave varying results even with different weights.
Yeah,
so it's not like it was just the same weight used the whole time. They changed the different weights.
We tried every variable possible to try and get mass to attract mass, and what we found was that everything that we did, it behaved in its own way randomly, and we couldn't control all the variables.
Well, physics students do it all the time.
No, they don't. But the point is, it's supposed to be repeatable. If it's true, we're supposed to be able to repeat it. Yeah, look, here's the building felt. This is the most dense weight that we found. This is lead, right? Lead is the most heaviest thing that we could find.
People do it all the time. So
no,
definitely
they don't, mate. We're trying to do it. You're watching us trying to do it, and it doesn't do it.
I probably couldn't do it.
So then people can't do it all the time.
It can't be done.
And yet
No.
you want people in a classroom to do it. Okay.
I definitely couldn't do it.
Right. So then people can't do it all the time because you just admitted that you couldn't
But
probably
physics
do it.
people do it. People who
Yeah, but we're
people
trying to
who
replicate
study
it. We're
this
trying
for
to
a living do it.
listen. Our goal is not to do any calculations and measure the density or calculate the density of Earth, which is what he says he was doing. All we're trying to do is establish whether we can get attractive forces between masses. That's it. Doesn't matter by how much. If we can say that we've got an attractive force between masses, that's our job complete. Don't care about the quanta. We just want to prove whether it works or not. And it's not doing it. It's behaving all by itself. And we couldn't isolate all the causes. We tried. We tried all of you anti-flat earthers to tell us what are we doing wrong. Change the twine. Earth it out. Do this, do that, do the other. And we tried it. We fucked around with it for weeks and weeks and weeks. And it didn't. Mass did not attract mass. So back to Cavendish. Even if we were to give you that mass did attract mass, which when we tested it, it didn't. But even if we gave it you, Einstein replaced it in 1915.
Well, that's just you there.
If mass did attract mass, then Einstein's theory on general relativity never needed to be invented or discovered or created or whatever word you want to use. Because that would be the true position right now. It still stands today, but it doesn't stand today. It's been replaced. Yet you anti-flat earthers keep citing it as though it's the current position, and it's not. It's been superseded, and you all ignore it. You know it's been superseded. George Musa told you it's been superseded, but you ignore it anyway.
So if mass attracts mass, why does Einstein's theory of relativity exist?
Yeah, mass doesn't attract mass. That's why Einstein's theory of general. If mass did attract mass, then Einstein's theory would immediately be debunked upon the minute he published it. Somebody would go, Cavendish proves this wrong, but that didn't happen, did it? Current science accepts it.
Sorry, before you go on to that, can I just quickly play like 5 seconds of this? Just listen to what he says, Dooch, about the apparatus.
There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated.
It is very difficult, yeah.
Yeah, so you said earlier that everyone can do it, and they do it in schools all the time. And we found that what his words were true, that we couldn't get it to work either.
Difficult.
Yeah,
that doesn't mean it can't be done.
So then not everyone can do it then, right? Like you said earlier on, everyone can do it.
Sure. So it's not repeatable. It's not scientific.
It can be done.
No, but it can't though, because we tried to do it and we couldn't do it.
Then try harder.
We did. We tried for months and it didn't work. We could never get mass to attract mass.
You couldn't get it to work. I probably couldn't get it to work. I mean,
so then everybody can't get it to work then. You said earlier that everyone can do it.
I probably could, if given enough patience and stuff. I don't really have patience though. Yeah, so, I probably couldn't do it. But people in physics do it all the time. That's like one of the first things you do when you get your physics degree.
Yeah, but we should be able to repeat it. If science it relies on science. Science relies on repeatability, so you can verify.
And it does get repeated by physics students.
Yeah, it's not though. It's not. Adam Meakin did physics, and he was unable to recreate it. And the teacher said it doesn't work, but we've got to tell you it anyway, or words to that effect. I'm paraphrasing, but the teacher admitted that they could never get it to work. You just expected to believe that it does work. But the point is not whether or not. Listen, the point's not whether or not it works. The point is, if it did work, it would immediately debunk Einstein, and everyone would go, Cavendish experiment, But it's only you anti-flat earthers that do that.
Einstein's general relativity does not exist. It exists not to contradict the notion that mass attracts mass, but to provide a deeper understanding of the nature of this attraction and how it fits into the broader framework of the universe's structure.
It doesn't fit into it at all. Einstein says that mass does not attract mass. It's not a force. Gravity is not a force in Einsteinian gravitation. Doesn't cause acceleration.
So Newton's law of
No, no.
universal gravitation.
Address that, please. Einstein's theory on general relativity does not state that mass attracts mass or that gravity is a force. It states the opposite. It states that gravity is an optical phenomena. It's an observed effect of the curvature of space-time caused by the uneven distribution of mass. It is more akin to refraction than a mass-attracted mass scenario. We see things on the horizon that appear to dance round over a time-lapse photography, and they're not actually moving, but they appear to move from our perspective because the medium is varying between us and the thing that we're looking at, the boat or whatever. And that's exactly the same phenomenon that Einstein's describing with bending space-time, but it requires billions of miles of distance, not just 10 or 20. It's not an acceleration, mate. It's an apparent acceleration caused by the warping of space-time, which is basically lensing. We see that in real world.
Theory, like Newton's theory of gravitational attraction, did not explain Mercury's orbit. It couldn't explain it. And it couldn't explain the bending of light, too, because light has no mass. Light doesn't have mass.
So what? What is your point?
I'm saying that for practical use only, it works.
It doesn't work. It isn't a force. It's not. No. Working, it means that it's a verb. It's not a verb. It's an adjective. It's describing. No, it's not a verb. If it was a verb, it would have to be a force.
You could look at it as a force.
Yeah, but it's not a force. You could think that my car's a Ferrari, but does it make it a Ferrari?
Wow.
I've got a little toy car next to me here. It's a Ferrari. It's red. It's got 4 wheels, tires.
That's not the same thing.
Right. So then it's not the same thing that when you can think of it as a force either.
It is.
No, it's not.
You're using...
If it was a force, Einstein would immediately be debunked, and all of the anti-flat earthers would be actual scientists, and they go, Cavendish proves that Einstein's wrong, but that did not happen.
Newton just made an observation.
Yeah, it was only ascribed to him.
Einstein described that observation.
No, hang on, listen, you missed about a big chunk there. What? Newton made an observation of an apple falling from a tree. It was only 100 years.
That's not really true.
Say again?
That story is not true.
It doesn't matter. The point is that Newton never ascribed a force of gravitation. That came 100 years out, 90-something years after his death by Henry Cavendish, A.G. Wells, and C.V. Boyce.
Huh?
Before he died, before Newton died, he said, I wish that you would not ascribe gravitation as an inanimate force to me. He knew that the idea of mass attracting mass was nonsense. It was 100 years after
he said
found
that.
In a 9 absurdity.
No.
100 years after he died, C.V. Boyce and Wells and Boyce, who was it now? C.V. Boyce and who was it? I can't remember. Wells and Boyce. C.V. Boyce and Wells ascribed gravitation as a force to Newton 100 years after his death. Newton didn't want gravitation being ascribed to him, but he did it. These two idiots did it to him. That's where the Cavendish test comes from. But it needed Newton to be long dead before they could do it and get away with it. And that's what they did.
Some of the things he's saying is true. Like, he didn't want it prescribed to him because he knew that in his theory, it sounded like mass just gravity just generated itself or something.
Can I read these exact words quickly?
I'll admit that what you're saying is partially correct, but
do control them
is one.
Okay.
Do control them plus so it makes it bigger so we can see it on screen because it's tiny. Yeah, there we go. Let me read it because I love this. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum without the mediation of anything else, by and through which the action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Gravity must be caused by an agent acting consistently according to certain laws, but whether this agent be material or immaterial, I have left that open to the consideration of my readers. He's talking about God. That last line is he's talking about God.
Oh,
And
God.
what he's saying is, if gravity does act the way that you're saying, it's got to be created by a third-party agent. He's talking about God.
No.
He doesn't believe God exists.
No.
He's saying it's ridiculous. Now,
Yeah,
if you want to still insist that it's
Do
true,
you know why he said that, though?
yeah, because it's
Did you
ridiculous to
research
think that mass
why
attracts
he
mass.
would say that?
Because it's ridiculous to think that mass attracts mass just by existing. Doesn't.
Did you, like, is that just you saying it, or did you research that was the specific reason as to why he said that?
He said he thought it was so manifestly absurd that no man of competent faculties, philosophical faculties, or whatever it was he said, could ever believe such nonsense. It's literally what he said.
But why did they say that?
Because it's retarded to think that mass attracts mass. He couldn't make
But
it any
that's just
clearer.
your thoughts on why he said that.
No,
Do you know
he
why
couldn't make
he
it any
actually
clearer.
said that?
He couldn't make it any clearer. He thinks it's ridiculous to think that a man can think that mass attracts mass.
I think because also, Luch, something you have to realize, he took it to his grave. He literally had CV Boys ascribe it to him after he died.
That would be like me saying that Luch was a flat earther after he died. That would be cruel, wouldn't it? Because Luch is not a flat earther, but if we all went around claiming Luch was a flat earther after you died and you weren't here to defend yourself and say we're lying, and then we said Luch did a test here, look, this proves that Luch was a flat earther and it proves that his claims are true, you'd go nuts, wouldn't you? But you'd have to be dead for us to get away
he
with it.
clearly stated he wasn't a flat earther. Exactly.
Yeah.
So as he lay dying, he said that it's absurd and stuff.
Yeah. Absurd. Anybody with a competent faculty of mind in philosophical matters cannot fall into it. He can't make it any clearer. He literally says you've got to be stupid to think that mass attracts mass. And that's why the second sentence exists. He says, if it's the case that mass attracts mass, then it must be being caused by a third-party agent whose rules of engagement or whatever it was he said are so unique to him that we just don't understand it. He's literally talking about God. He's describing God. Now, I'm not even a God person. I know there are people that may well be, and I'm not dissing them in any way. But he's describing God. He doesn't even believe in God, but he's describing it. That's how stupid it. You've got to either. Read it again. Just put it back on screen. Let's read that last sentence again.
Yeah, but he knew the limitations of his work.
No, he's denying that mass attracts mass.
No,
literally,
he knew that his work had limitations. Like
no. His work doesn't include mass attracting mass. It doesn't have limitations of mass attracting mass. It doesn't mass doesn't attract mass. He says it.
It did not explain how that force was transmitted through space.
Yeah, he says it must be created. It must be created by an external agent. Well, the only external agent in space would be God. Yeah, make it bigger. Yeah, here we go. Let's read what it says again. Pay attention to the God bit. This is the only bit I want you to understand. He says, gravity must be caused by an agent, that will be God, acting constantly according to certain laws, that'll be God's laws. But whether this agent be material or immaterial, why does he say that if he's not referencing God?
You're taking it out of context.
I'm not. What else can he be talking about? Give me an alternative.
Okay, read it for me again. It's too small. I designed
Gravity must be caused by an agent acting constantly according to certain laws, but whether this agent be material or immaterial, I have left agent open to the consideration of my readers. Why would he say?
Okay.
Why would he say that the agents must be material or immaterial? What else could he be talking about if it's not God?
He doesn't know what he doesn't know if it's
So why-
material or immaterial.
Yeah, so there's only
He
one
doesn't
thing that you
know
can
how
possibly
it's
be.
transmitted through space.
What? Say again.
He doesn't know how it would be transmitted through space.
No,
That's
no.
why I said that there's
No.
Stop.
there must be
Remember,
another,
he understands you
there's
need a
another
causal agent.
explanation for
Sorry.
us.
No,
He
no.
knows
So you
you.
said he doesn't understand. He says, so that one body may act upon another at a distance, that would be through space, through a vacuum, without the medium of anything else, by and through which their own action and force may be conveyed from one to another, is to me so great an absurdity that I believe that no man, that will be Luch, who has in philosophical matters a competent faculty of thinking, could ever fall into it. So if we assume that Luch has got a competent faculty of thinking, he's saying that Luch could never believe it. So one of two positions must be true. Either Luch does
Right.
not have competent faculty of thinking, so he does fall into it, or he does have competent faculty of thinking and can never fall into it. It's a true dichotomy. One of the others is true. So which is it? Are you of true competent faculty of thinking, or are you not of?
I'm gonna take a photo of this.
Yes, you take a photo of this. And when you go back to your friends to tell you how to interpret this nonsense, then you can come back and tell us what nonsense you're going to get back.
Let's say.
Let me just try and make this clear to you. Remember, Newton understood that you required a causal agent. In other words, you required a force for a mass to accelerate. He had no foundation for that force to exist.
Correct.
Literally.
Newton's applying his first law of motion, and he's saying there's got to be a force that does it. But whether it's material or immaterial, he leaves that open to his viewers, right? He's literally saying it's got to be God doing it. But he doesn't believe in God. So the only alternative is that it doesn't exist because there's no God for it to cause it in his understanding, because he's a God denier. He's literally a God denier as far as I can tell. He might not be, but I believe that's how he
was
saw
an
God.
alchemist. He was an alchemist.
Yeah, he didn't. I don't believe he believed in God. I think he denounced God. Whether God exists or not, he denounced him, right? But the thing is this. He did not believe that two objects, be it planets or stars or whatever, they could not convey a force through. It says it there. He says gravity should be innate, inherent, and essential to matter, so that one body, like the moon, may act upon another, the Earth, at a distance through a vacuum, without the mediation of anything else, by and through which the action and force may be conveyed from one to another, is to me so great an absurdity that I believe Luch could not have, in philosophical matters, competent faculty of thinking. Luch could ever fall into it. Yet here we have Luch falling into it because he believes that the moon can attract the Earth. And Newton's saying that he doesn't believe that Luch, if you've got competent faculty of thought, he doesn't believe that Luch can do that, but you're doing it. Dude, it goes back to this. If Newton was correct, Einstein would have debunked, but he would have been debunked straight away by all of the anti-flat earthers that would have been actual scientists at the time, and they'd have gone, no, because Newton got it right with the Cavendish experiment. But that did not happen, and you can't accept it.
Einstein just gave a description.
But again, if he was right, then all of you scientists that were at the time would have been piping up saying the Cavendish experiment demonstrates that Einstein's wrong. It isn't the warping of space-time causing the apparent acceleration perceived by Eddington in 1919. It is a third-party agent, inanimate or otherwise, or gravity. He would have been citing Newton. But they didn't do it, did they? Now, so Einstein didn't have... He had a massive chunk of critics. There's books about how many critics that were against Einstein for a variety of reasons, and it doesn't matter what, but he had his opposition, and he still does. And people have claimed that he's wrong. Not everybody accepts Einstein, but mainstream science does.
Action at a distance.
Yeah, you're not listening, are you? You're still trying to fight. You're scratching round frantically, like you're on the deck of the sinking ship while all the rats are scurrying away. and you're still doing searches right now for something that you
Doesn't
can.
that mean that one object can affect another through empty space without any physical contact or intermediate
No.
substance?
All the mass does is warp space-time. Think of an orange in a sock. The sock goes round the orange, and that's all that mass does. It warps the space-time between you and the object, but it's got to be observed over millions and millions and billions of miles. And the effects of it are so small that it's basically not even worth talking about. But the point is, it's not mass attracting mass. It doesn't cause acceleration. It causes perceived acceleration.
So that's why he voiced his discomfort about his theory.
Let's just place it this way, Luch. He could understand that you need a causal replication for it, and because there's nothing in a vacuum, there's nothing to cause this acceleration. Einstein came out and said, well, let me give you something to cause it. I'm going to call it a mathematical space blanket that warps.
That,
yeah, you're laughing.
his
But that's
discomfort was that an object can affect another through empty space without any physical contact or intermediate substance. This was like a conceptual challenge because it didn't fit into the mechanical philosophy at that time, you know?
So
that's why he left it up to other people to find out more about.
No, he left it up to other people to find out more because you have to be lacking in competent faculty of mind in philosophical matters to be able to go and find out more that you're describing. He literally says it. Dude, listen.
It's you're taking it out of context, though.
No, I'm not. I'm not. I'm explaining
you
it to you.
context.
No, I'm not taking it out. Okay, all right.
Makes sense.
Let's go and check the context. Have you ever read Einstein's theory of general relativity? Yes or no?
I haven't read the book. No.
Okay, so I'm going to show you it now. Let's. I can't remember. Share screen. I want to share a window, and I want to share. This. Right. So, do you see Einstein? Do you see the gravitational field on screen?
XIX, the gravitational field. Yeah.
This is Einstein's theory of general relativity. This is the context that you say that I don't understand. Okay? Let's read together. If we pick up a stone and then let it go, why does it fall to the ground? The usual answer to this question is, quote, because it's attracted by the earth. That's what you idiots would say. Notice that he uses a stone, right? If he'd have said helium balloon and it fell to the sky, would it be attracted by the clouds? Hypothetical question you don't need to answer. Anyway, he says because it was attracted by the earth. Now, pay attention, right? Modern physics formulate. This is why I say current science, because he says modern physics. I say current science formulates the answer rather differently for the following reason. As a result of the more careful study of electromagnetic phenomena, we, being science, have come to regard action at a distance as process impossible. We have come to regard action at a distance as process impossible, Luch. What does that mean?
Without the intervention of some intermediary medium.
Yeah. So process impossible. What does he mean when he says this? This is the context that you say I don't understand.
But without the intervention of some intermediary medium.
Yeah. But if space is a vacuum, there's no medium, is there?
There would be the bending of space-time.
Yeah, but that's not the point that this paragraph's saying. Let me read it again. As a result of the more careful study of the electromagnetic phenomena, we, being science, have come to regard action at a distance as process impossible without the intervention of a medium, right? There's no medium up in space, is there? So between two planets, say, for instance, Mercury and Saturn, Jupiter and Saturn, there's no medium in between. It's the vacuum of space. It's devoid of a medium. So what does he say? We regard action at a distance as process impossible. Luch, what does that mean in the application of Jupiter against Saturn?
have a look-see.
Just read it. It's black and white, mate. This is the context that you say that I'm misrepresenting. Come on. As a result of the more careful study of electromagnetic phenomena, we have come to regard action at a distance, that would be the attraction of Jupiter between Saturn, as process impossible. Come on. I know it's French, but what is it saying? Process impossible. What's it saying? Come on. You know this.
So process impossible.
Yeah.
So what does that what does process impossible mean?
Yeah, we've come to regard action at a distance, that's mass attracting mass, in a vacuum, as process impossible. What does it mean? Come on, say it. We know you know what this means. Come on, Luch, say it.
Isn't that like action at a distance?
Yeah, mass attracting mass, action at a distance. That's exactly what he's describing. This is the context that you said I was misrepresenting. Come on. In the context of Jupiter and Saturn in a vacuum. Listen, Jupiter and Saturn in a vacuum. He's saying we have come to regard action at a distance as process impossible. What is he saying? That what's not? Come on. We all know that you know what he's saying. I want to hear you say it. Can't do it, can you?
Force concept.
No, he's not saying force concept. Come on.
While he's trying to figure it out, I just want to quickly read out a super chat. Thank you very much, Tony Whitcomb, for your £10 super chat. He says, Luch, you like mechanical, right? Look how railway lines are made. They are made horizontal to meet the next rail to the next rail. No curve taken into account. Thank you very, very much. And that is a true statement. You rock. Thank you very much for your
Why
super chat.
would there be curve taken into account?
But that's not what you're concentrating on now. Concentrate on impossibility. What does the word impossible mean? But thanks very much for this.
Not gonna happen at all. It's
correct.
Impossible.
So when he says we have come to, he's talking about the scientific community, right? And he's part of it. We have come to regard action at a distance as a process impossible. So in other words, the process impossible action at a distance of Jupiter and Saturn, for instance, in a vacuum is impossible.
But what about without the intervention of some intermediary medium?
So let's just say that there was an egg, and we'll call that Jupiter.
It's impossible without the intervention of some intermediary medium.
Yeah, because my egg in a vacuum is not going to accelerate towards anything, is it? It's just going to stay there, not doing anything. But if we were to put it in a medium, like he's saying here, maybe there could be some element of acceleration, which this literally was one of the reasons why I did the egg test. Because if there's a medium, he's acknowledging medium, he changes it in a minute to something else, but we'll see it. But for now, I just want you to, we've already got you to acknowledge that it's impossible, right? But let's carry on reading, because you said that I was misrepresenting the context of his of Newton's quote. And I'm not, because this is the context of what Newton's saying. He thinks that it's absurd to think that mass can attract mass. And he's now admitting it in 1915. We now consider the action of the action at a distance as process impossible. So I'm not misrepresenting it at all.
So now we must ask, what is
No, we don't. We can carry on reading.
Medium.
No, we can carry on reading, right? If, for instance, a magnet attracts a piece of iron, we cannot be content to regard this as meaning that the magnet acts directly on the iron through the intermediary empty space. What he's saying is it's not the magnet that's attracting the iron, something else is happening. But we are constrained to imagine, after the manner of Faraday, that the magnet always calls into being something physically real in the space around it. That something being what we call a magnetic field. So he's saying that magnets don't attract things. He's saying the field that's around the magnet is what's causing the acceleration, not the magnet itself, the field that's around the magnet.
So for electromagnetism, the intermediary is the electromagnetic field.
Magnetic field, yeah. But Earth's not a magnet, so it doesn't have a magnetic field. But he's using this as a simile, as a comparison, something that you can get your head round. So it's not the magnet itself that's attracting matter; it's the medium that's around the magnet.
It's a field that extends through space and mediates the electromagnetic force.
Yeah, but you need the field to exist in the first place, right? And we see that with magnets. There's no dispute that magnets have got a field. You can line up the iron filings, you can see the direction, they all line up and you can see it. Nobody disputes this. But the field exists, right? We all agree. Yeah?
Yeah.
Great.
Magnets
Sorry, before you go on, I just want to shout out another super chat quickly. Thank you very much, Retroball, for your 10 USDs. Really appreciate it. It says the kingdom of pseudoscience is like a merchant seeking fine pearls, who, having found one pearl of great price, sold it to buy a NASA t-shirt. That's so true, man. Thank you very much for your super chat. Really appreciate it, man. You rock. Really appreciate it.
But
Yeah.
what we have to do is look at what the intermediary field would be for gravity.
No. So what Einstein's now doing is change the word medium into field. So we've made a quantum leap where he's now equivocating between,
and that the intermediary field for gravity would be that would be the fabric of space-time itself.
According to Einstein, that would be the fabric of space-time. But just notice what he's done. Einstein has gone from an intermediary medium and he's now conflating it with field, right? Let's just be aware that's what he's done. He's conflating the word medium with field. This is important. You'll not get it for now, but Flatzoid will get it.
Maybe
anyway,
they both mean the same thing.
No, they don't, because a medium and a field are not the same thing. Because my egg sat in a medium of salt water, but that doesn't have a field around it. It couldn't be described as a field, but it can be described as a medium. But they're not.
Okay, maybe it's just.
I think I have a way of explaining it to you, if you don't mind.
It's not him conflicting words. Maybe it's talking about something different.
I'm going to try and explain in a very simple way to maybe understand. The medium would, for instance, be a water in a bucket. The field would be the movement inside that water.
Uh-huh.
Yeah.
Well, I don't think there is a field in with water, but anyway, it doesn't matter. But let's
no,
continue.
But you understand?
Reading.
I'm saying the movement. I'm just giving an analogy.
Yeah.
Just so he knows there's a medium, and the field is the movement inside that medium.
Yeah.
You
so
can't
with the
have the field without a medium.
So with the egg test, it would be the Brownian motion. That would be the field, because all the particles or all the molecules are bouncing around freely in all directions, as they are inside a gas chamber when you put a bit of gas in it and then try and weigh it and claim a calculation instead of a measurement. But the point is that the medium is acting in a certain way and it's freely in all directions. But anyway, let's carry on reading, because this is where you said that I was misrepresenting it or I was misquoting it or whatever it was, out of context. So let's carry on. It says, in its turn, this magnetic field operates on the piece of iron, so that the latter strives to move towards the magnet. We shall not discuss here the justification for this incidental conception, which is somewhat arbitrary. We shall only mention that with its aid, electromagnetic phenomena can be theoretically represented much more satisfactorily than without it. And this applies particularly to the transmission of electromagnetic waves. The effects of gravitation are also regarded in an analogous manner. This is a total. Einstein is basically creating a non sequitur and also a baseless assertion fallacy here. There is no reason why there should be an effect of gravitation that behaved in this way.
Yeah,
it is a baseless assertion.
It replaced the Newtonian view of gravity.
Ooh,
because the Newtonian.
Did you just say replaced?
Newton saw gravity as a mysterious force acting across empty space without a physical medium.
No, he didn't. He didn't. But you just said that this replaced. Did you mean that word, or was that an accidental misspeak?
Space-time distance. Gravity is the result of mass and energy curving space-time, and bodies move along the path that dictated by this curvature. This replaced the Newtonian view of gravity as a mysterious force acting across space-time, empty space without a physical medium.
Do you realise what you've just said? This replaced da-da-da-da-da.
Uh-huh.
Well, that means that Newton's was no longer considered to be current because it replaced it.
Uh-huh. Uh-huh.
Therefore, mass doesn't attract mass because this
But
replaced
that-
it. No, I don't
it's
even
Newtonian.
agree with this. This is nonsense, but this is what is mainstream science. This is what science is today. They think that Einstein is correct largely. I'm not saying he's perfect, but they think he's relatively perfect. Some people don't agree.
Yeah.
But mainstream science accepts Einstein replaced Newton. Yet you're
Uh-huh.
still trying to tell me that mass attracts mass. You've just admitted that it doesn't.
But it does.
You've just told me that
Okay.
Einstein replaced
Okay,
Newton.
wait. It's an apparent attraction then.
So it's not an acceleration then, is it? Because an apparent attraction doesn't cause an apparent acceleration. But
But
in
we
what
can,
you tell us is
we can
Cavendish
definitely
experiment.
observe the attraction.
No.
between mass-
Do we see an actual acceleration, according to you? Do we see an actual acceleration in the Cavendish experiment, or is it an apparent acceleration?
It would be an actual acceleration.
It would be an actual acceleration, yeah?
Yeah.
Yeah, so you need an actual force for that because you need Newton's first law of motion to be complied with. An object at rest, which would be one of Newton's lead balls, will remain at rest unless acted upon by a force, an unbalanced force. So it needs to be a force, not an apparent force. It needs to be a force.
Why do you agree with his first law but not his second?
It's not that I don't agree with it. It's just that you replace the first law with the second law because you want to calculate forces into existence. Newton's first law doesn't allow you to calculate forces into existence. It requires that you demonstrate and identify the force, not calculate. It's easily debunkable anyway. You can demonstrate very easily that if you apply a force to a mass, it doesn't always accelerate. Like if you lean against,
you can definitely see an apparent attraction between masses, right?
No, you can't. We tried to
can't
replicate
be.
that. No, you can't. We've been through this. We tried to replicate this theory that mass attracts mass, and for months it was undemonstrable. It doesn't happen. We couldn't get it to do it. Yeah, hillbilly blue balls will shuffle around in his garage as though it happens easily on demand. Click his fingers, and all of a sudden he can get it to do it.
I mean, he is like very smart.
Oh, so I'm stupid then?
Like, no. Oh,
So do you understand that when Cavendish did his so-called test, he had to do it observed through a telescope through a hole in the wall, and he couldn't be in the room because he admitted himself that by being in the room, it created air currents that disturbed the air, which would cause acceleration.
Yes,
Right.
I agree with that. Yes.
So why do you give hillbilly blue balls a pass for shuffling around in his garage? Totally violent. That's not even repeating the Cavendish experiment. He's in the room. Can't be in the room.
Yeah, you can't be in the room.
Right, hillbilly blue balls was in the room, and you think that's okay because he's intelligent? Are you for real? You said that he was intelligent.
Wait, what did he do?
He was shuffling around in his garage whilst he was performing the observation that he was demanding that was causing mass and attracting mass. And you think that that's a pass because he's very intelligent.
No.
We actually called him out on this, that he was actually going and knocking his wooden apparatus to get the oscillations.
It doesn't matter.
Yeah, that's not that wouldn't be an accurate experiment then.
So now you just said
you wouldn't be able to get any accurate results from that.
So I just want to say thank you, Adam Meakin. Sorry, guys. I just want to say thank you, Adam Meakin, for your £2 super chat. Good to have Tony back. Really appreciate the super chat, man. Yeah, that's an awesome discussion, I have to say.
I agree with you, Sleeping Warrior. That wouldn't be a very accurate, you wouldn't get any kind of accurate result if you were in the room with the Cavendish experiment. Your mass would be getting in the way of getting an accurate result.
But he does claim accurate results consistent with the mass attracting mass claims of the Earth and Newton.
Maybe he meant another one. or something.
Or maybe
I
he's
don't
just fucking lying.
know.
He can't be in the room. Cavendish wasn't, well, Boys and CV Boys and H.W. Wells were not in the room when they did the Cavendish experiment. They did it through a telescope and a hole in the wall. Yeah,
Yeah.
Blue Marble Science is shuffling around in his garage, and he's on camera. You can see him in the garage at the same time, creating all sorts of turbulent air movements. He's got air conditioning units that are creating warmth through, I think it's called central air. I might be wrong, but he's got heating going on in that garage as well because it's like cold. Like,
Blue
dude,
Marble Science.
Hillbilly Blue Balls. You must know who I mean. The guy that repeated it in his garage. Have you not seen it?
No.
Right. I assumed that you knew who I was on about. So that whole conversation can be scrapped if you don't know what I'm talking about. It's fine. But let's go back to the theory. Let's go back to the theory of general relativity for a minute, because I want to nail this point on that you said that I was taking it out of context when I cited Newton. I didn't cite it out of context. You've already admitted that it replaced. So I haven't taken it out of context. The context is specific. He thinks it's retarded. He thinks it's absurd. I'm paraphrasing. To think that mass can attract mass without an intervening medium. And I agree with him. My egg would not accelerate without me manipulating the medium. But that medium manipulation has got to be there. Otherwise, that acceleration ain't happening.
That would be the fabric of space-time. That medium thing, whatever.
Do you know what is the fabric of space-time? Is it actual or is it conceptual?
It would be actual, wouldn't it?
By definition.
It's like putting a ball on a blanket and seeing how it bends.
Yeah, that's a false equivalence. That's a really poor. They say that space is flat, but they need space to be flat so they can use that example that you're describing. But when you put an orange through a sock, it curves the sock around it in all directions, not just flat. It's in all directions, 360 degrees.
They used it to discover Mercury, so it must be pretty good.
No, they didn't. You misunderstand. They used it to calculate the effects of the apparent retrograde motion of Mercury.
That's all they discovered that I think it was Neptune had a weird orbit or something.
Yeah, and they used it. But Galileo discovered it 200 years before they made the mathematical calculations. It was that's a Texas sharpshooter fallacy where they already knew that Neptune existed. So they needed a way to make it sound credible. So they said, let's make a prediction that there might be another planet here that we already knew about.
Oh, I think it was Pluto, wasn't it?
No, it was Neptune.
They didn't know Mercury existed.
I was going to say thank you very, Tony, again for a £10 super chat. He says, Luch, if the Cavendish was an experiment, why did the traction be sideways and not to the mass of the Earth underneath? Boom. Thank you very much for your super chat, man. You rock. I really appreciate it.
Because the masses were introduced sideways.
So torsion twist.
No, they made sure there was no torsion twist in the.
But that's what Cavendish reads: is torsion twist oscillation by torsion twist.
Yeah. You need to not have any twist in there. You need to isolate. That's one of the things.
No, that's what it reads. That's what the data reads is torsion twist.
Yeah, you need to get rid of that. No torsion.
No,
twist.
That's what it reads.
Yeah, isolation of the torsion twist.
It doesn't get rid of it. It physically reads it. The data is oscillation based on torsion twist. So in other words, torque.
What does
Have you ever read
mean?
the Cavendish data before? The papers?
No.
I can tell. And then I just want to say before you and Anthony go on again, you see this is Blue Marble Science contraption in his garage. Can anybody tell me what the issue is here with everything around there? It looks very cluttered with different masses everywhere, doesn't it?
Yeah, I think the main problem is that the little balls in his experiment are being attracted to his belly more than they are to the weights that have got him. The mass of his belly is causing more of an attractive force between masses. And because he's continually moving in the room and disturbing the turbulent air, I mean, Cavendish himself said that, H.G. Wells and whatever they were called, CV Boys and H.G. Wells, they both said that it's so sensitive that turbulent air would cause accelerations that they could never rule out. And here we've got Hillbilly Blue Balls walking around with the biggest mass in there, and he's affecting it according to he shouldn't be in there.
Technically, you could do it in
No,
a
you
room
couldn't.
cluttered with stuff.
Even in the Cavendish experiment. Have you ever read the Cavendish experiment? I'm guessing not.
No, but
Should we
technically you could do it in a room cluttered with stuff. You can just introduce another mass into the cluttered room to see if there's any attraction towards that mass.
No, you
You
couldn't.
have to see if it changes in any
You couldn't,
way.
mate.
And it
Mate, we
works.
tried doing it. We tried putting masses in there. We tried to double the force of the mass by putting them on opposing sides of the spinning torsion bar, and we couldn't get mass to attract mass. It behaved erratically and randomly in all directions for no obvious reason, and we were unable to control all variables. Yet Hillbilly
Then
Blue
you
Balls
did it
was able.
wrong.
What? No, we
Because
didn't do it wrong.
you yourself couldn't explain why it was acting like that.
Yeah, but Hillbilly Blue Balls, whilst being in the room with turbulent air and things moving around when they shouldn't be, he was able to apparently replicate it perfectly in accordance with the Cavendish experiment and the size of the Earth.
Maybe there's some things you missed in that. Maybe it wasn't turbulent air.
Luch, will you quickly read on screen what it shows you? Weights moved from midway to positive position, and then weights moved to negative position. Would those be two different vectors?
Two different vectors? Like two different movements?
Yeah.
Yeah. Right? Yeah.
Thank you. Do you know what all these things are? This wording, all this what's on screen?
No.
These are the oscillations due to torsion twist.
So this is them isolating certain.
That's
things?
the data that was read. So in other words, torsion due to torque.
Oh, you say. Oh, you said oscillation, not isolation.
Oscillation.
Ah, okay. I thought you said isolation. My bad. Okay, the oscillation of.
There you go, Tony. You're back on screen, man.
I'm just trying to find the actual Cavendish paper so that we can go through that as well. Because,
but is it fine with you guys if you're only going for another half an hour? It is reaching 1 o'clock to me.
Oh, the movement back and forth in a regular rhythm. That's oscillation.
Yes.
Oh, it has a.
Do you have Flatzoid? Do you have a copy?
Regular variation in magnitude or position about a central point, especially of an electric current or voltage.
You want me to
That's
send you the
electromagnetic
paper?
oscillations.
I'll put it in the private chat for you guys. There's the citation.
I want the PDF, the actual document.
I can try it down, but I've got the link that I gave you there. I don't know if I can get the actual PDF. You can probably save it as a PDF if you want to. But I'll put the link.
I think I've got it here.
There we go.
I've got it. Yeah, this is it. If this still works, this link, this is it. Here we go.
Retrable, I won't even attempt that.
Here we go. Are you looking at my screen, Flatzoid?
Yeah.
Right. Can you see my screen, dude? I'm sorry, I forgot your name.
Luca.
Luca, yeah. Can you see my screen?
Yes.
This is the paper that was submitted to the Royal Society of the Cavendish experiment. That's not an experiment, but we're going to read what it says. Bottom of page 2, right? This is the front page. So ignore the first page. It's introductory, but the second paragraph, the second page. It says, in order to determine, I'll read it from here. Mr. Michel had prepared 2 wooden stands on which the laden weights were supported and pushed forwards till they came almost in contact with the case, but he seems to have intended to move them by hand. Listen to this, pay attention. As the force with which the balls are attracted by these weights is excessively minute, not more than 1/50,000,000th of their weight, it is plain that a very minute disturbing force will be sufficient to destroy the success of the experiment. And from the following experiments, it will appear that the disturbing, let's go over the page, force most difficult to guard against is that arising from the variations of heat and cold. For if one side of the case is slightly warmer than the other, the air in contact with it will be rarefied and in consequence will ascend, whilst that on the other side will descend and produce a current which will then draw the arm sensibly aside. Now he's admitting how sensitive it is. Now we found that it was very sensitive as well, and we found that it did other things. But anyway, the point is the point is that he's making is that it's very sensitive, and the movement of air, just the fluctuations in now he's got his heater on in that room when he hillbilly blue balls when he does his thing. The heater's running, so it's putting warm air in there so he's not cold because it was in winter if I remember correctly. But the point is, even if he didn't have his heater on, there is convecting currents in that room. Every time a door opens, every time a door closes, cold air comes in, warm air goes out. It creates movements of air, and they admit that they should, and that's why they were not in there. If you read what it actually says, they demonstrated, or they tried to do this with a hole in the wall and a telescope. And that's how they were doing it. There's an article, a drawing in here somewhere, and they weren't in the room.
Yeah. You need to completely isolate and account for every variable.
But they said that the one that was most likely to cause accelerations was the turbulent air. Now, the only way that they could really negate that is to do it in a vacuum. And you know what? You know what? There are no Cavendish experiments done in a vacuum. It's not. There are no experiments of the Cavendish experiment done in a vacuum.
But
But no.
Let me have a look. I think there was one.
No.
Let's say.
And you know why there isn't one? Because it doesn't cause math doesn't cause attraction. Something right. The thing is, the turbulent air. All he needs is a slight air, a warming of air in one corner, and he's going to create a convection current, and it's going to behave the way he wants when he turns the air on, the warmth on, and create a current. And that's I don't know how Hillbilly Blue Balls did it. I don't care how he did it. The point is, this Newtonian gravitation had been replaced. You use the word replaced. If this was still valid, all of the anti-flat earthers that would have been scientists at the time would have gone, Cavendish experiment proves that Einstein's wrong, but they didn't do it. And Einstein is still considered to be correct today. So even though you believe it, it's not current science.
I just asked, was there such thing as a vacuum in the 1800s?
Since you're never going to get a complete vacuum, but they have done it in vacuum conditions, like vacuum chambers and stuff.
No, they haven't.
Let's see. Modern versions of the Cavendish experiment are often conducted in a vacuum. Yeah, or at least under partial vacuum conditions.
Evidence for that. Not just someone saying it, but show us someone doing it. Because it doesn't do it. There is no...
Sure you can look up the data and maybe even video of it.
No, you're the one that's making the citation. It's on you to demonstrate it. And we've looked for it. We can't find anything anywhere of a Cavendish experiment done in a vacuum.
But does that make sense, though? In the 1800s, there was no such thing as a vacuum when Cavendish did this, okay? Why would you get the same results then today if it is in a vacuum?
Because what we say is it's the same. gravity, mass attracts mass always, so why would it be different?
It doesn't. I know you think it does, but it doesn't. It's been replaced. It's not been like that for 100 years. I know you think it does, but that doesn't make it so. It might make it in your mind, but it doesn't make it in anybody else's mind. I realize that you were taught this in school, but that's the problem.
Literally, you can do it yourself.
No, you can't. We've tried. It didn't work. Yeah, we're shit. But we couldn't get it to work for months.
Many people have done it.
No, they haven't. They're lying to you. I know that they tell you that they've done it, but show us the evidence of it. Because we've showed you what we did and it didn't work.
But you also heard how sensitive it can be.
It didn't work, mate. If we could get it to work, I would be the first one out there saying, yeah, mass does attract mass. It was consistent with what we found. And then you'd have people like Flatzoid that would say, hang on a minute, show me what you did. And then people like, I don't know, Brian's logic would try and then do it the way I did it and get results that were consistent or not. But we couldn't even get the phenomena in the first place. Mass did not attract mass.
Yeah, I think the argument should be, are you claiming this is a scientific experiment, Luch?
It is an experiment, yeah.
Is it scientific, though? That was the word.
Yeah, it follows the scientific method.
It didn't follow scientific method. There's no observed phenomena in the first place for them to think, maybe mass does attract mass, because we don't see it in the real world. Where do we ever see mass attracting mass?
Things falling to the ground.
Yeah, so dandelions blowing laterally across the ground that don't get attracted to the ground. They follow the wind. They don't fall down, do they? Helium balloons rise. Clouds go up. Clouds then stay up.
We have a natural down direction.
We don't.
When we jump, we fall back down. There you go.
Yeah. So if we jump in water, do we fall back down or do we go to the top?
Because of buoyancy, we would.
Regardless of what it is, do we see the phenomena of down when we jump in water or not?
If we do like a pin drop, we would go down.
Right. Answer the question that I asked. I agree that in air we do fall back down. But in water, if we jump in water from the down position and we jump up, do we then go back down or not?
We go up.
Right. So we don't go down then, do we? It's medium specific. Why is it that an anvil will float on mercury and when you try and push it below the mercury, it still brings back up? No, not buoyancy. The medium, you're changing the density of the medium. There's no such thing, dude. There's no such thing as buoyancy. Gravity doesn't exist in the first place. You can't have, you can't have sirloin steak without a cow.
But if you think about gravity existing, it answers your question about why things would get heavier in a vacuum chamber.
So if I think about a cow,
an unanswerable question that you asked me of why things get heavier in a vacuum chamber gets answered if gravity is involved, if buoyancy is involved, you know?
No, because right, you need gravity to exist in the first. Right, listen, we had the example with the cow and sirloin steak, right? If I just think that there's a cow on my plate, do I then get sirloin steak?
Obviously not.
Right, so why would you think that you can get buoyancy if you just think gravity exists?
But we demonstrated.
No, you haven't. You haven't. And Einstein said it's no longer the case. You literally read it with me before. We have come to it, we being science, we have come to accept. Let me read it again so I get it right. We have come to, what does he say? As a result of the more careful study of electromagnetic phenomena, we have come to regard action at a distance as process impossible without the intervention of some intermediary medium. So he's acknowledging, and we're in a medium, right? We're breathing it. You can call it air, whatever it is. It's definitely a medium. It's not a vacuum. So we're in a medium. So without the intervention of an intermediary medium, we being science have come to regard action at a distance as impossible. But you're still saying that it's a thing. It clearly is not.
Thankfully, Einstein came up with the bending of space-time, the fabric of space-time.
Which you said it yourself.
which would be the intermediary medium.
Yeah, which
It
replaced
would be the fabric of space-time.
yeah,
That's the medium.
which replaced Newton's theory that wasn't
Yeah.
even Newton's. Yeah, right. So
So
gravity's not a force
this-
then.
So this
So gravity
proof
is not a force
is
then.
correct. It's impossible without the intervention of an intermediate medium. That
Yeah,
medium
and
is
you haven't got a
space-time.
medium in space, have you? You've got a vacuum, which is the absence of a medium.
The fabric of space-time is the intermediary medium now, so there's no problem.
Which replaced Newton's theory, which was that mass attracted mass.
We've
So
got
by-
space-time.
Right. So by extension, you haven't got a force to cause buoyancy. So when
But
we
we
take the
can
medium,
literally observe mass attracting mass.
no.
So-
Listen, you're not following it logically, right? Einstein replaces Newton. You said it yourself, replaced, right? Einstein says that we have come to regard action at a distance as process impossible without an intervention of some intermediary medium. We are in a medium; it's air, right? So we've definitely got the medium that we can act on, that we can say that there might be some kind of interaction with. But because Einstein replaced Newton, that means that you haven't got the force of gravitation to give you the buoyant force to explain why it is that when you remove the medium in a vacuum chamber, the object in that vacuum chamber gets heavier, because you think that there's a downwards acceleration of the air called atmospheric pressure pressing down on it. So therefore, if you remove that downwards force pressing down on it, it must get lighter, but it actually gets heavier, and you haven't got a buoyant force to cause it, as you claim, because gravity doesn't exist. Even if you think it does, it doesn't, because I'm thinking that I've got a cow on my plate now and I haven't got sirloin.
But if we assume gravity does exist, then the question gets answered, right?
No,
Buoyancy.
because just because you think something's true doesn't make it true. It just
I mean,
makes
it could
you
be.
believe it.
I mean, it could be evidence for it.
No, it's a delusion, mate. Just because you think that doesn't make that so. It's in your head.
It's a hypothesis that we
It
will
is
need
not
to
a
test.
hypothesis. Remove that nonsense out of your head. It is in your head only. It is definitely not a hypothesis.
I hypothesize that
You don't know what. Listen, you don't know what a hypothesis is.
I hypothesize that buoyancy is real, and my observation is that things get heavier in a vacuum. There you go.
There we go. On screen, Luch, can you look at the two dates quickly and tell me what's the issue here for you?
246 BC. Any object totally or partially immersed in fluid or liquid is buoyed up by a force equal to the weight of the fluid displaced by an object. Archimedes' principle allows the buoyancy of any floating object partially or fully immersed in a fluid to be calculated. 1687 in Cibolos, the magnitude of the attractive force F is equal to G, the gravitational constant, a number the size of which depends on the system. Oh, I know. I'll maximize.
Don't worry about that. Just what's the date? Problem with the dates?
246 BC and 1687. This date, 1687, is more recent than 246 BC.
Okay, and 246b is buoyancy, correct? Archimedes principle.
246. When was Archimedes' principle discovered? It's buoyed up by a force equal to the weight of the fluid displaced by object.
The point is, you don't need gravity for buoyancy. Gravity came in almost 1,900 years later than Archimedes' principle, dude. It's literally, buoyancy is not gravity based.
I'll have a look. let's see that. When was Archimedes' principle discovered? Let's see. And at the same time,
In other words, can you show
so
us
you
GM
think
equation for buoyancy?
so? You say that buoyancy can't be anything to do with gravity because gravity came up later than buoyancy.
Yeah,
No,
they had
because
ships
gravity-
working.
No,
So
buoyancy
nobody
can't be
knew
anything to do with
gravity
because
existed.
gravity didn't
And-
exist, mate.
but-
Buoyancy, right? Listen, I said it before. I can't think a sirloin steak into existence just because I think I've got a cow on my table. But I need a cow to get sirloin steak, right? I can't have sirloin steak with no cow. You can't have buoyant force without gravity. Even if you think gravity exists as a force, doesn't make buoyant force exist because it neutrally, objectively, no longer exists as a force. It hasn't done for 100 years. Just because you think it doesn't make it that it does. It's a delusion, mate.
So because buoyancy came up in 246 BC, and gravity came up in 87. You're saying that buoyancy does not include gravity because it couldn't have, because gravity was thought of later.
Well, it's been superseded by Einstein. It came up later. It was wrong. Mass doesn't attract mass. There's loads of reasons. Pick one. Doesn't matter which.
I forgot how
Dude.
to spell buoyancy.
Dude, let me ask you this. If you went and did a Cavendish experiment yourself and you couldn't get it to replicate, would you still believe it anyway? Or would you say, I couldn't get it to replicate, so I'm not sure?
Well, if it had been done before, and if I couldn't get it to replicate, then I'd still believe it, because it had been done before.
It hasn't. It doesn't work. Science has to be verifiable. If it is not verifiable, then it's just nonsense. There's no such thing if it doesn't exist. You have to. We need to be able to repeat it, otherwise it's just not true. Literally, it's that simple. You've heard of Hitchens' razor before, right? And Occam's razor.
What's that? Occam's razor. I've heard of it, but I don't know specifically what it says.
Hitchens' razor says that which Hitchens' razor is that which can be asserted without evidence can be dismissed without evidence, right?
And
yes. There is no evidence for mass attracting mass. I know you think that there is, but there isn't. There isn't. It's medium specific. It depends on the medium, and some masses don't. Even in our medium, some masses don't fall to the earth; they rise. But helium balloons being the best example. Clouds, vapor, smoke. Anyway, you've heard of Hitchens' razor as well, right? Occam's razor. The conclusion that has the least amount of assumptions is often correct. Yeah.
Yeah, is that a fallacy?
No, it's just a razor of philosophy.
Okay.
If you've got a really complicated explanation and you've got a really simple one, the simple one's usually correct because it requires the least amount of assumptions.
That doesn't seem right to me.
Okay, it doesn't matter if it seems right to you or not. It is a thing. It's called a philosophical razor called Occam's razor, right? But there's a one that's really important to you here, right? It's called Alder's razor, Alders, Alder's razor. It says, if you can't settle something by observation or experiment, it is not worthy of debate. You cannot, and nobody in your side of the story, and it is a story, can show that mass attracts mass. Doesn't
But
do it.
we can't with the
No, you
Cavendish.
can't. I know you believe you can, but you can't. It's
But the
very
Cavendish
easy.
experiment.
No, it's very easy to falsify. It's impossible to recreate without falsification. Doesn't happen, mate. We've tried it. We tried it because we wanted to know, did mass attract mass, and it doesn't do it. So just because you think it, we've tried it and it doesn't work. But it needs to be repeatable, demonstrable, and verifiable. We need to be able to verify it to be true. Look, if we could verify it to be true, I'd be the first one pushing it, because mass does attract mass in that case. But we were unable to repeat it, and we spent months on it. If something's not verifiable, it's not scientific. And if it's not repeatable, it's not scientific. If you can't demonstrate it with experiment, you've got to apply Alder's razor, mate. There is no experiment that shows that mass attracts mass. It doesn't happen. It's just a folly that you were told in school. They lied to you in school, mate. I know you believe it, but you believed Santa at one point, right? You were probably about 6, 7 years old when you worked out Santa wasn't real, because you didn't have a chimney and you always wondered how he got to your house when you haven't even got a chimney. Probably 6 or 7. How old were you when you realized that World Wrestling, Ultimate Warrior and Hulk Hogan and all that? How old were you when you realized that that was fake?
What? The what? What's fake?
Wrestling. How old were you when you realized that wrestling was set up?
Well, I have to say, right at this very moment.
So you think wrestling's real?
Yeah.
You got to be joking, right?
Wrestling is like punching and
No,
stuff.
Wrestling, Ultimate Warrior, Hulk Hogan.
Oh, I'm thinking of boxing. Okay, yeah.
You realize that wrestling's fake, right? They've got storylines that they have. 1 week it'll be this team that wins. Next week it'll be that team that wins. They have a set storyline and they're going to stick to it because that's what they get paid to do. Did you realize that wrestling's not real, right? Or
I'm
not?
not sure.
Oh, right. Okay. Well, listen, I got news for you, buddy. Wrestling's not real. They've got storylines. They've got pre-predicted position. I'm not saying that they don't get injured. I'm not saying that the slap to the face or the punch to the elbow or whatever. I'm not saying none of that happens. Yeah, they do get injured. It's true. However,
so you think it's staged?
Yeah, of course it's staged. I'm shocked that you've not come across this already.
Well, I haven't looked into it before.
Come on.
You know if they need them to bleed, they even put blood bags on them that's covered in mascara and stuff. So when they hit them with a chair or something and it ruptures the bag, then they think it's real blood. It's literally staged, man.
I'm shocked that you've not met this already in life. I mean, how old are you?
Yeah, I guess I agree with you. Yeah, okay. Wrestling is staged.
Yeah, it's staged, set up. It's not real. It would be so much more entertaining if it really was real, because it would be genuine people fighting and stuff, wouldn't it? But it's not. It's orchestrated. 1 week you get this guy wins, and then the rematch, he might win or lose the rematch, but it's orchestrated because they get paid to play in a certain way. Entertainment. That's why they're all registered on IMDb as actors, because they are actors.
Yeah.
But if you recognize that Santa's not real, and now you reluctantly acknowledge that wrestling's not real.
Nah, I acknowledge that wrestling's not real. Not reluctantly.
So not reluctantly, what was the word that you accept?
Wrestling is fake.
You do accept
fake.
Yeah, you accept that wrestling's fake, right?
Yeah.
Okay. So at some point after 7, but before tonight, you accepted at some point that wrestling was fake, right? At some point, you're going to realize that gravity's fake as well. It's just an adult version of Santa. That's all it is. I know you were taught it in school. You were lied to.
No.
Yeah.
Wait,
you were lied to.
Why specifically this, though? Why lie about specifically this and nothing else?
Well, you know, in the parable, in the parable, which is like the Emperor's New Clothes, there's a little kid that stands out and says, "Daddy, why is everybody thinking that this man's dressed up when he's in the nude?" Nobody said, "Why are they lying about the dress?" They all just accepted that he was in the nude. Nobody questioned the motives. They just pointed out the fact.
It's like a cartoon movie thing.
What?
The Emperor's New Groove, was it?
Clothes. The Emperor's New Clothes.
I've
only
seen the Emperor's New Groove.
The Emperor's New Clothes. Only intelligent people could see that he was wearing the finest of attire. If you couldn't see that he was wearing finest of attire, you were not intelligent, because only the intelligent people could see it. So basically,
you were perceived naked. That's right. Yeah.
Yeah. The king was walking around in the nude, but only intelligent people could see.
I remember now. Yes. Yes, that's right. Yeah.
Yeah, but only intelligent people could see it. So if you could only see the king in the nude, you weren't intelligent. Could you see the king wearing his new gown? I could see the gown. Could you see it?
Yeah.
You could. So you're intelligent then, aren't you? Because you could see the gown.
Yeah, but obviously they had to make it like that so it wouldn't be weighted like MA 15 plus.
Yeah, but the point is, he was in the nude.
Yes, he was.
Yes. But when that became apparent, they didn't say, well, why did they lie? They just accepted the fact that he was in the nude. So the question that you asked is, well, why would they lie to us? Who cares? They are lying, though. There's no science for what you believe.
Everyone needs a motive.
Maybe they do, but I don't know their motive.
That's just a movie, though.
Maybe they do, but I don't know their motive. Why would you think that I would be that intelligent to know their motive? Because you don't give me any intelligent credit before now. You think I'm stupid?
You believe that.
Say again.
No one really needs a motive in a make-believe movie.
Yeah, money. They sell the movie for money at the box office. That's their motive.
No, I mean, like, in the movie itself. They don't want me to explain everything in the movie itself. I mean, sure, having the explanation would be
everybody helpful. In a movie that's telling lies, they've always got a motive. It's usually money, a woman, a job, car, you name it. There's usually a motive. It doesn't matter what it is.
Yes.
They've just got one.
Yes.
Right. So there's definitely a motive.
People in the world, though.
Yeah, I know, but you don't give me any credit. You think I'm stupid, right? But now you're asking me to define their motives as though I'm super intelligent, and I don't understand how you can have it both ways. If I'm stupid, I couldn't
even know how to determine their motives either.
But why would you think that I would? Because you asked me why would they lie, and I don't know why they would lie. I just know that they are lying.
How do you know that they're lying?
Because there's no science for your nonsense. Gravity doesn't exist as a force. There is no science for your delusion. Gravity is the adult version.
How did they discover Mercury then?
Who cares? Gravity is the adult version of Santa.
No, you saw that comment, huh? On the YouTube channel, I saw that gravity equals Santa or something.
I've been saying it for donkey years.
Equals Santa equals gravity. I saw a comment
I've been saying that gravity is the adult version of Santa for donkey's years. It is. I know you were taught it in school, but if you'd have gone a little bit beyond school and you went into further education and then higher education, you would have been taught, if you studied physics, you would have been taught that Newton's wrong. And then the next thing you'd have been taught was Einstein. And then you'd be asking all questions that we were asking when we worked out that Einstein was the current physics. And he's not even the current physics, by the way. He is the current physics by mainstream standards, but it's claimed that he's been debunked by other people in science today. But that's not the point. When we learned that Einstein is the current position in science, we all wanted to know why we taught that Newton was correct. And the answer is because we were lied to. I don't know why. but we were.
I mentioned this to Flatzoid as well. On our very first debate on the Luchu special, of how, it would be like less than 1% to find 20 people from different countries, different ethnicities, just 20 random people from around the world, and they all would lie about the exact same thing, which has a estimated less than 1% chance of happening.
Yeah, but they're not. The majority of those people are not lying. They're just doing what you did, which was reciting what they were taught in school. It's not lying though. There's no intention to deceive, apart from when you've looked into the topic and you've realized that it's not the current position in science, but you still push it anyway. You're lying. You know that gravity is not a force, but you push it anyway. That is literally lying. But if you've never looked in this topic before and you've only just come to it and someone tells you that gravity is not a force and Einstein said so and he's the current science, you're not lying at that point when you start questioning it, because you're asking all the obvious questions like, well, why would we get this in school and blah, blah, blah. No, it doesn't create a force. It creates an acceleration. It's an actual an apparent acceleration. It's not a force, mate. Stop saying that. You've been brainwashed by Fight the Flat Earth because he's lying to you in the same way but his motive is because he wants money. He will tell you all day that gravity is a force. And if
we should end this soon.
No.
So needs to get to bed.
If you pay him, he will suck your toes for you. He will do anything for money.
I mean, if you find any person that probably suck your toes for the right amount of money,
yeah, and he's one of them.
Yeah, he won't even mind, even if he got toe jam.
If you pay him more, he'll suck the toe jam off for it as well. Yeah, you've got to pay him more for that though. But his motive to lie to you is money.
But that doesn't necessarily mean that everyone's motive would be money. People have different motives, different incentives.
I didn't say it did. But Conspiracy Cats, you know who he is, right? The teacher.
I've heard of him being brought up by FDFE.
Yeah.
But so I haven't actually seen his content.
He teaches children. And I said to him, if you knew that gravity was not a force, would you still teach it to kids? And he said, yeah. And I said, why? He said, because that's my job. He knows that gravity. This was when before he was overtly dishonest. This was when he was making genuine inquiries and he was asking all the right questions, the way that I did, the way that Flatzoid did, the way that everybody in this topic on my side, we all asked the same kind of questions, and he was doing that. And I said to him, if you realized that gravity was not a force, would you still teach kids that it was? He said, yeah. I said, why? He said, it's my job. So he admits that it's lying. He admits that he knows that if gravity is not a force, he will still teach it to kids anyway because he gets paid to do it. So the reason why teachers will pay, I believe that, and I accept it because I believe that he's speaking the truth when he says this, teachers will still lie to children because they get paid, and they will justify it because they say, quote, it's their job. In exactly the same way that when, let me think of an example. In the Holocaust, when all the Germans were killing all the Jews and they were giving them the gas chambers and all that, and their defense was, it was my job. Ultimately, it wasn't accepted. The Nuremberg trial said that just because it was your job does not give you the right to kill people just because it was your job. And they were all found guilty of war crimes. But
yeah,
Conspiracy Cats accepted that even if he knew that gravity wasn't a force, he would still teach kids. Now, in his defense, he didn't get taught physics. He did biology as his major in science in his university degree. He never did physics, yet he teaches physics to kids. So he's teaching them or he was, I don't know about now, but he was at the time. He teaches something that he's not skilled in, he wasn't taught professionally in, and if he was taught professionally in, he would have been taught that gravity is not a force and it's been superseded by Einstein. But because he wasn't taught that, he didn't know.
Then he shouldn't be a physics teacher if he didn't do physics.
I completely agree. He should not be.
Okay, guys, I think we're going to end it here tonight.
Okay, yeah. It's like 2 a.m. for Flatzoid.
Going on like 3.5 hours, over 3.5 hours. So I think it was a good discussion. We can always do another one if you guys want to. I'm
Yeah.
enjoying it. I do
I
enjoy
think
it.
we made four. I think we made 4 key points there, and I can't remember exactly which they all were now in order. But the bottom line was, we established that there is no downwards acceleration due to gravity, so therefore atmospheric pressure by definition doesn't exist, because if it did exist, the objects in a vacuum chamber would get less heavy, but they get more heavy. Immediately debunks it. We've established that, what else? That a set of scales put on all 6 sides of a cube will measure a so-called weight, but only when the particle hits it, but it works on all 6 sides of a cube. So then, again, there's no downwards directionality because they're bouncing freely in all directions. We established...
The first one is answered by buoyancy. The second one is answered by... it's only in theory.
We established that you'd cited a document from which you were reading from, and when I challenged you on it to produce it, for whatever reason you were unable to produce it. So we established that you were not able to rely on that citation because you couldn't show that it was true, and therefore we dismissed it because you couldn't show it was true, and therefore I accept that you were lying. You were lying about that because you couldn't prove that you were not.
I'm still gonna assert that I'm not lying.
Okay, you couldn't prove it. And there was a 4th one. I don't remember. Flatzoid, do you remember what the other point was that we discussed?
Yeah, gas moves in all directions. The gas.
Oh yeah. So the idea that atmospheric pressure is only in the downwards directionality is a direct contradiction of the free movement of gas, or the dual expansion of gas law, which you denounce because you say it's conceptual only. But we all know that it's a gas law, and that's the science. So you can deny it if you want to. You've got to deny it because it debunks the downwards directionality of gas, according to you. So it debunks that. You have to deny it. But I mean, they're the key points there that you're not going to take any seriousness to at all. You're just going to forget about them immediately and when this conversation ends. But I'm the one that denies the science, according to you. I'm the stupid one because that's what you've been told about me by people like Fight the Flat Earth. But when we've gone through it, you're the one that denies all the science. You're the one that cites from a document and then can't produce it. You're the one that will basically, you'll lie to people because reasons. But I'm the stupid one. No worries. No further questions. I'm done.
But yeah, I just want to say thank you for Retro Paul for his super chat, $5. He says, a future civilization will find a recording of this debate, the only relic of humanity's past. That's hectic. Imagine they do see this. But yeah, I think it was an awesome chat. Obviously, Luch, you got a lot to go actually look at, and I do really think it's your cognitive pain that's keeping you from seeing what's really happening. We're trying our best to explain it to you, but I have to give ups to you, Luch, because you do conduct yourself really well. I mean, some of the people we talked to, they would have rage quit ages ago. So I have to give big ups to you for that.
Thank you.
And yeah, Anthony, awesome stuff as always. Still a work.
Thanks for having me.
It was awesome. Nice.
You're gonna go away and completely forget all the points that we discussed, aren't you? They're not going to even register.
Well, it's here to let him rewatch, so.
Yeah, but you're going to ignore them, though, aren't you? You're going to rewatch it and you're going to ignore them anyway.
No, no, that's not entirely true. I did look up lots of things that you were talking about, so I did have some interest. I didn't immediately know how to refute your claims, so
you can't refute my claims. I didn't make any claims, mate.
I didn't immediately know the stuff you were saying, so I had to look them up.
I didn't make any claims. The only claim I made was that you're telling lies when you added a bit there to the citation that you relied on and then wouldn't produce it. That was the only claim I made.
Well, I still had to look up other things as well, which I didn't know the answer to right away. So
you should look them up, and then you should wonder why it is that. Well, basically, you crashed and burned on every point that was made, mate. You died.
No.
You did, mate. You died. I know you. If you want to think that you did well there, you can. I can't control your thoughts.
It's a mutual disagreement. I agree that you were wrong, and you agree that I was wrong.
Whatever.
We're saying the opposite things.
Okay, but yeah, thanks for coming, guys. I appreciate it. It was a great chat. Appreciate everybody in the YouTube lands as well. Thank you for everybody that hit the likes and shared the show. Really appreciate you all. And thank you for all the super chats and everybody that really supports this channel. I'm going to bed now, so I'll see you guys again tonight again. Lately, it's this whole week I've been saying I'll see you guys tonight again. So I'll see you guys later. Thank you very much for everything. Many